Hi, Costas. Nice to see you.
Hi, Jeremy.
Thank
Good
you.
to see you.
Yeah. We'll just give people a few more minutes to
Of
trickle.
course. Take your time.
Yeah, no worries.
Can I do a quick check to see if I can share my screen?
Yes. Do you have the YouTube open in the background, Costas? I think there was a feedback, or maybe it's me.
Let me
No, I
see
think
that.
it's me.
I can probably use it on my phone. I just don't want to split my screen now.
No, actually, just don't worry about it. It's something on my end. Do you have the YouTube open? There. Yeah, go ahead. Try and share your screen.
So very quickly, you can see this.
Yeah.
And then I want to check this as well. Okay, cool.
Perfect.
Okay.
Perfect. Looks good. All right, it's 11 o'clock, but I don't know where everyone is. Maybe it's early on the West Coast. So why don't let's wait maybe 2-3 minutes and then we'll
Okay.
start.
Can you also link the YouTube URL here so I can share it internally to my team?
Absolutely. So the YouTube's in the chat if anyone wants to share it. It's also linked to right from the program. So if people want to look at the program, there's an embedded window there where you can just watch it straight from the program. All right, well, let's get started. So welcome everyone to day 2 of BTS 2023. As I mentioned yesterday, I'm Jeremy Clark. I'm at Concordia University. Concordia is in Montreal, Quebec. As I mentioned yesterday, I'd like to acknowledge that Concordia is located on unceded Indigenous lands. In this case, it's the Kayonkahaga Nation. So today's program, as with yesterday, it was planned by myself and my co-chair, Adi Mashatan, who's at the Toronto Metropolitan University. So yesterday it was all academic talks. So I apologize to anyone that's not an academic, but today should be much more interesting to you. So we have lots of talks from people in industry, we have people from government, R&D, think tanks, that type of thing. And if you are an academic, we have some student presentations at the very end of the day. Okay, so without further ado, I'll introduce our first speaker, Kostas Halgias. I hope I say that right. So Kostas was, I mean, he's worked on lots of different things. He's currently a co-founder of Missin Labs. They make the SWE network. Before he worked on R3 Corda. He worked at what was then called Facebook Libra, though the names of both of those things have changed. And I just want to say one thing, I'm gonna make one plug. Libra, like most people here know about it because of the whole like regulatory response to it. It was in the news. But what you might not know is they had like an absolutely stellar A-team of people working on it. And a lot of the technology that was built for that project is super interesting. And I don't think it got like sort of the attention that it deserves. So Kostas might bend your ear a bit about that, or he might talk about some of the new things. We'll see. But anyways, I'll turn the floor over to you.
Yeah, thank you, Jeremy, for the introduction. By the way, let me share my screen very quickly. A moment. So yeah, I'm coming from Facebook. I used to work in another company even before Facebook, by the way. It was the permission blockchain called Corda from R3, so in the UK, London. I have experience in practice from 3 blockchains, one permissioned, one from Facebook that was supposed to be permissionless. And you know all of this like regulation criticism and back and forth. Eventually, we didn't manage to launch back then. Many of us left from Facebook, not because the technology obviously was not good. I can tell you for sure, I mean, I can sign it because I was part of the crypto team. I implemented most of the stuff there. Technologically, we were ready. And imagine personally, I had to take like paternity leave for every month, like the year 2021. And then I couldn't get it just because every single week was a launching week. And then never the green button was pressed. And eventually this is where we are. Many of us actually left Facebook. And at least 3 or 4 blockchain companies have been created as spin-offs after the collapse of Libra. And the reason that this happened is obviously all of the investors and like the community believed, at least on the technology side. Facebook was a bit more, apart from the regulation side, I can say like my personal view here, it was growing too fast into this. And while the shape of the blockchain industry is actually moved fast, very, very quickly in order to create all of this hype and get from the community some hype as well. But if you are in a large organization, things are typically more slow. And eventually, that's the reason all of these startups actually emerged from the collapse of Libra. Today, and this actually started from Meta, I can guarantee you that there was literally internally to Facebook some satellite divisions of the cryptography team working on, if we launch, how are we going to do proofs of solvency? And we don't want to have the same issues that Bitcoin had at the very beginning, like with the empty box collapse. And then afterwards, you see what happened to FTX and all of this. Let's explore what are the options for all of these exchanges to be solvent, or at least prevent bankruptcy by having some signals before this happens. And this led my team, including Payman, Lera Nikolaenko, that is now on A16Z, and some other people at Facebook, to work on the crypto transparency solutions. I will say now we have Jeremy here. Jeremy, I was inspired by your provisions paper. Without this, nothing would start even at Facebook, I can tell you for sure. We explored the protocol many, many times. We made eventually some optimizations on this to make it practical for Libra. And then eventually, as you will see now, even some governments were interested on this protocol. And as you can see, it's not only for solvency. You can even see how, even while at Facebook, I was ready to propose a system to the parliament of many countries, how they can do transparent COVID-19 reports, because for a while, nobody believed the reports from the government. And some other things that you will see, one at least country in the European Union was interested on this algorithm for tax evasion protection. So you can do the same things that Provision started all of this, like the paper from Jeremy, all of this industry, how we can use it outside solvency. So I'm going to go directly to the topic of how this can be used in other places. So here is the problem statement, right? We have a particular class of auditing where the audited entity, let's assume in the solvency case, an exchange, a bank, doesn't have any incentive to increase their liabilities or obligations. So in your particular situation, imagine you have your money in your bank. How do you know that your bank is solvent? In practice, there is fractional solvency in the banks, like they don't have 100% of the deposits in their vault. They usually keep around 4 to 10%, maybe 12%, depending on the restriction, and all of the rest are invested. So, but in any case, even these percentage should be able to be audited somehow in order to avoid situations where for some reason for a month you go under this 4% and what's happening then. The applications are obviously at least 3. It's on finance, as I explained with the banks. But the same thing can be used on e-voting, and you will see why. And eventually on official reports, like, as I explained before, any pandemic report like the daily cases that each government, each health organization is publishing the daily basis when this happened. And the recommended approach, and what is the problem typically with these options, is all of your banks, all of the blockchain exchanges, even the governmental reports are typically audited or not audited by third parties. Imagine the big 4 like Deloitte, Ernst & Young, PKMG, and all of the rest. But the problem is the person, like the people who are actually part of these liabilities are not involved. I don't know if any one of you have been called to actually check that your balance is there as part of the solvency requirement of the bank, right? Nobody, it never happened. However, if we had the ability to have the people, those that actually are the liabilities of the bank, of the exchange, to participate in this process, then even the government or the exchanges or the banks or even the auditors have an extra tool to actually help them to do the audit. This is what's happening here. The random sampling, and you will see how zero knowledge proofs actually fits here, is not necessarily happening by the auditor or some agencies. It's happening by the users themselves. And that's, I mean, now in the back of your head, in the back of your mind, you will have all of the information. Now, if everyone can check the daily cases, I'm positive, right? Is my case actually reported up to in this amount that the government is reporting? If not, something is happening. Maybe they are cheating on the results. So this is pretty much the whole idea behind it. So the problems here, and I can tell you for sure because I'm working on this since my early days at Facebook. We started at 2019 exploring the solvency part. If I remember correctly, Jeremy, your paper was at 12-15, and then it was also bulletproof where you could apply general zero knowledge proof on top of this thing. So in practice, it's not a technology that is there for more than 10 years, right? It's like 7-8 years at most where we started to have cryptography to work on this stuff. The problem I realized by participating in other conferences, including ZK Proof, which is like the one for zero knowledge, they try to even standardize stuff. The community in general, after like the NSA days where NSA and NIST was deciding on the standards, is now less actually able to propose new standards just because there are many opinions. So in zero knowledge proof, we have at least 10 algorithms out there, and nobody has standardized one of them. So we can at least move with something. And then we have, as we have RSA signatures and ECDSA signatures, to have a standard that people can use. So in practice, what we try to do, we said, okay, let's start with the most basic one of the most like mature, which was bulletproofs, and see if we had bulletproofs, which is a zero knowledge proof algorithm, can we apply this scheme that is more understandable, I mean, from the majority of people, like the early engineers on the space, and actually work on top of it without every single month we get a new zero knowledge proof scheme and see if it applies to this solution. Because imagine, we have to do with bankers, we have to do with auditors. These people are typically more conventional and more conservative, and it's very, very difficult to go and change technologies every single time. So it was a big problem back then, and then we proposed as Facebook, I mean, while I was at Facebook, some standard, and we tried to extend from this one. The aim is to fix the consistency in the industry. You cannot imagine what I found when I audited all of the exchanges that they did proof of solvency. To tell you the truth, I haven't found a single one that is doing it correctly. And you will see a few names. Some of them have made some improvements, at least in the last year. But literally before 2022, I don't believe any of the exchanges that could actually share the data that we are solvent, we're providing you cryptographic proofs, were actually 100% transparent. Even if they were, they couldn't prove it because all of the algorithms in practice were broken. And I will explain what I mean with this. And the problem is there is no standard, right? And here I'm trying to explain what are the options we have and what people are doing and how did we find like huge, very important bugs in all of the exchanges that propose at the moment, blockchain exchanges, because the banks are still behind in financial solvency via cryptography, and why they did it wrong. So the non-goals in this particular case, I'm going directly to the bottom of this slide, is some situations require some extra features. For example, if you use this technology that you will see here for e-voting, obviously you have to defend against coercion and bribery and some other features that typically e-voting has to preserve. And at the same time, you will see that another issue is you don't want people who try to verify their inclusion, the agency or the exchange or whoever it is, to know that you in particular try to check your inclusion, because if they have this information, they know who is a good citizen and who is not. And in practice, if they see that Jeremy never checks his balance in Binance or a particular exchange, let's remove his balance from the next liability proofs, right? So ideally, we want to hide this information as well. We don't want to know who downloaded what. In short, the proof of solvency, I will go to the financial element now, and then we will extend it gradually to all of these applications I described in the previous slides. So typically you have some liabilities and you have assets, right? Liabilities for a bank are the deposit of its users, and the assets is the investments of the bank, the gold that they have, the dollars that they have in their vaults, and everything they need. And in practice, we need, at least when you're 100% solvent, that the assets are more or equal to the liabilities. This is the problem we want to solve here. And this is how it's working at the moment. Imagine this is a regular bank. You don't even need to know that it's a blockchain. But in practice, what's happening is you have a decentralized, you have an exchange at the moment, like all of the Coinbase, Binance, and so on. And on the left side, you have the users who have some amount and they can see it on their wallet. And on the other side is what Coinbase and Binance owns in the real blockchain, right? Their addresses and the balances that they have. And what you want to ensure is if all of the users one day go and withdraw all of their money, can they get it back? Do I have enough assets on the blockchain so I can sell everything and pay back my users? So this is how we're actually formulating the problem. And in this particular case, we will not care about what's happening on chain, because in theory, what Coinbase could do is publish all of their addresses. And maybe if you do some scanning on Ethereum or even our blockchain and so on, you will see which addresses belong to which exchanges. This is typically easy just because they don't use one address per user. They typically go to the omnibus model where they have, 100 accounts, and with these 100 accounts, they accommodate all of their users. So it's typically very easy to track what they have. But at the same time, I recommend to you to read the provisions paper. Since the provisions paper, I haven't found a very good, until last year actually, where people from George Mason, they published a paper that is using MPC, how you can prove your blockchain assets with privacy, right? Provisions was the first one, like Jeremy's paper, where they said, okay, if for some magical way, we had the situation where all of the exchanges are audited at the same time, we can ensure that they cannot transfer balances to each other and actually cheat the system, right? Because if you know when you are audited, what you can do is Coinbase is sending 1 billion Bitcoin to the other exchange. The exchange passes the solvency. Then the other day it's Coinbase's time. Binance will send back the money, and then Coinbase will be solvent again, right? So for this to work, and it's a very difficult problem, that's why we're only dealing with the left one at the moment. How can you ensure that the audits are happening at the same time? In my opinion, Jeremy and everyone here, the main issue is you need at least some restriction to ensure that this is happening transparently and pretty much at the same day, if it's possible, at least for the very big exchanges. And this is a problem, right? However, liabilities can happen anytime, because now you have users use their mobile phones and they use everything. And in theory, if we had an automated way, every single day on the background, your app is checking, hey, today Coinbase reported the total amount of money they have as deposits on their platform. Am I included on this amount, right? In privacy, with some private methods. So that's the idea here. And then as you can see, what's happening in practice, you have all of this, like an exchange doesn't have only Bitcoins. They might have Bitcoins, Ethereum, Sui, Solana, Polygon, assets, everything, right? And in theory, the user only has one app. This is how now we're trying to see, okay, based on the one app that the user has, and assuming all of the blockchain addresses were public, can we check if Coinbase or Binance, if we add all of the deposits there, are actually meeting the equation, or that they are at least less than the assets? Previously, we had the following issues, right? In the past, like 2014, we had the empty GOX in the blockchain space, where at least almost 1 million Bitcoins have been stolen. And in practice, I don't know, back then it was for 50 million. With the current price, imagine how much money it would be. And then the problem back then was, even before this happens, right? Because if it happens, it's anyway dead end. I mean, you cannot do anything. But even before, can you see the progress of the balance of the exchange? If something happens one day before, and it's not like a single event that actually makes you insolvent, because for this, you cannot do anything, right? If one day an exchange goes and sell everything on chain, and like all of their balances are zero, the user doesn't have a lot to do. They can only go to the court. But the problem is, can we ensure that gradually we get some information that every single month, every single week, we get an attestation that there is solvency on the exchanges? And this is how it started with the empty GOX. I believe it was your inspiration, if I understand correctly, Jeremy, right, to write the provisions paper, because this was a problem even on the real economy, right? We had the Enron case in the past, where maybe with the auditor, they did some colluding or whatever happened. And in practice, do you trust, even if there is an auditor, do you always trust the auditor? And for us, I mean, like people who are living in Canada or in European Union, maybe in the US as well, maybe you don't care about corruption sometimes, but imagine how many countries do have like some restriction that is shady, and you don't know exactly what's happening between the bank and the auditor on the system. You need the users to participate. The first thing, right? What can an exchange do? The first thing that they can do is publish everything. So individual wallet balances, you can see my balance everywhere. Even if you don't see me as an individual, you will see some hash or something. But in practice, if you want to be transparent, you will publish everything. And you can do the total calculation. Everyone can go there and see, oh, my balance is in this total report. I'm good. I see that the total balance is 25. Oh, I also see the blockchain addresses owned by Coinbase. It's also 25. Coinbase is solvent. But there is a problem, right? The problem is, even if you do this to the auditor themselves, not publicly, first is if we trust the auditor in general, right? Do you trust the auditor? Let's assume that you don't want to publish everything into the like the external world to any observer, and you go to the auditors. Okay, this is option B. I will do with an auditor. First, I'm not sure if they're colluding. And the second thing is the auditor is learning more stuff than they should. They're not only learning that you're solvent, they're also learning Jeremy's account, Jeremy's strategy, Jeremy's balance, my balance, everyone's balance, the performance of the wallet. Imagine if this is happening every day. Someone who has this information, they can go to Binance and see, oh, what is the stock of Binance now worth? I see some decline before they officially announce the results of how many users they have and what their balances are, right? So if we had this information public, even to the auditor, there might be a situation of internal trading, like someone has extra information that they shouldn't. And what happened in the past is people actually, you know, in 2014, Mike Harn actually was one of the first developers of Satoshi. I wouldn't be in this position if I didn't work with Mike, who actually hired me in R3 like 8 years ago. And Mike actually was one of the auditors of Bitstamp, one of the exchanges back then. And what people did, because they didn't trust the auditors, they were getting some reputable people from the industry, and they said, okay, can you please do a query in my database, see all of the balances, get the sum, and actually report it, putting your signature there. Hey, hi, Mike, I did this stuff, and then I prove to you that their master database has the amount that they're reporting. And the same thing actually happened with other people, right? And then in 2014, there was an announcement that was saying, until we can implement full zero knowledge cryptographically, we trust the auditor. We cannot do anything else. And now we have zero knowledge proofs. So there is an option C. The option C was the following. The option C was actually publicly available without necessarily requiring an auditor. And what you do is you are taking the balances of each users, you are putting them in a tree. I guess, Jeremy, I guess the audience knows what is a Merkle tree, right? Or I have to explain this as well.
I mean, you can maybe take 30 seconds to explain.
Okay, cool. So what is a Merkle tree? Okay, first, I assume you know at least what is a hash function. A hash function is a one-way function. If we go, like if we do the operations, we cannot go back. We don't know exactly what was the input that derived this outcome. And then assuming you have this one-way function, you put all of the balances in some layer, like the bottom layer, and then pair by pair, like 2 by 2, you concatenate them in a way that you say, okay, let's assume that we have user A and user B. I use the left elements at the moment. There is a balance of 11, and this is the hash of the user. I don't want to reveal all of the user ID. And I also use an audit ID as a randomness information to hide what the user ID was. So each user is provided with an audit ID. Let's assume that this is a random number. You have your user ID, which is your email. And everyone probably can see the leaves of the tree. It's fine if you see the leaves. However, what's happening is you see a hash, so you don't see the identity, but you know someone has 11, right? Someone has 9, someone has 14, someone 16. And the Merkle tree works as following. You get the elements at the bottom. You hash the value of the elements like 1 by 1, and then you do, and this is a summation Merkle tree in particular. So apart from hashing left and right, you're also doing the summation of the balances. So this was proposed pretty much that period, like 2014, 2015, and then hash to hash to hash to hash, eventually, I mean, like a playoff situation, you go up to the root, right? There will be a Merkle root, and it will have the full amount and the full sum. And the Merkle root will be a hash of something. So imagine what's happening here. If you are a user B in this particular case, I will provide you with a Merkle path up to the root. And because we explained that cryptographically you cannot go back from the hash function, if you get all of your siblings, then eventually you can go up to the root without requiring to send you the whole tree. So user B can now get all of the gray elements that you see here. And obviously they know their audit ID and the user ID. They can produce the second node here. So they need this left gray node to produce this hash. And then, okay, with this hash, you need something on the right. So I'm sending you this as well. And then eventually you go up to the root. So each user just gets a path, which is reasonable. Even if a tree, imagine, is like consisting of 1 million users, the path of the tree is at most 20, right? And 20 hashes, sending 20 hashes plus like a balance is not a big deal. This is fine. I mean, people can receive it on their phone. It's okay. Every user can check their proof up to the root. The problem is what's actually without zero knowledge proofs, what is revealed here, right? So to the auditors, you still expose individual wallet balances. You hide the identity, but you still expose the balances. You're also revealing the number of customers. If you know the bottom layer of the tree, you know exactly how many customers Coinbase has. And there is a situation where you are also leaking from multiple proof of solvency, some of the user balances, if this user is who, because if you see the number 11 again, and consistently you see number 11, probably, and with the same hash, probably it's the same user that is actually not moving their assets, right? You're learning also stuff between proofs of solvency. And then you're also learning the total liabilities. Sometimes we don't want to reveal this, right? You don't want to reveal how much money Coinbase has on their accounts. In the customer side, however, let's assume that the customers only get their proof here, their path. They are learning some Merkle path balances. So you know there is another user next to me that has a balance of 11. And there is another like account where 2 users have a number of 30. So you're learning something because you're doing like this path to the root. And obviously, if some people collude, they can learn balances from many users. And if you are lucky and you are next to Mark Zuckerberg and you see some millionaire next to you, you know exactly, oh, there is a millionaire in Coinbase with 5 million Bitcoins. And then you're learning many, many things, right? You can even learn the customers, because even if you see a path, pretty much you know if the path size is 20 hashes, it's probably 1 million users, from 512 to 1 million. And you learn the wallet performance, of course. So, by the way, this happened, I mean, the real auditors started to do auditing on the blockchains in 2018. Deloitte was the first company doing that. And as you can see, back then they used pretty much this technology that I'm saying now. And you realize that there was some leaking happening on the liabilities and the wallet performance. There is another, before we go to ZK, there is another option to do it without like very expensive zero knowledge proof techniques. Split the balances. What if instead of putting 17, actually this method that we proposed it in, we call it Maxwell++, 2020, because people were a bit reluctant to use zero knowledge proof just because of the problem that I told you at the very beginning. They didn't know which technology to use, and they were not very familiar. They didn't have a cryptographer in their team. They didn't feel comfortable. Anyway, let's do the following, right? Let's get balance 17, split it to some values, smaller values, and then shuffle them and somehow get more leaves now than the number of users. However, each leaf has like a smaller balance here. And the situation is resulting like all of this, if we put it in a tree, it's resulting to this thing that you see at the bottom. And now just focus here. Now you can see that, oh, we have something from one user, which is a pair with something from another user. We're not learning everything now, right? But we still learn something. We still learn some of the balance. So if you see that someone has two next to you, there is at least one user who has a balance of two. And imagine now we're talking about balances in like blockchains and exchanges. What if the same method was used for COVID-19 reports, and this was reports by hospitals? You know that this hospital has two, but the other had one, but you won't necessarily to reveal this. You only want to reveal the final number. So this also had some leaks, right? And still the total liability is visible to the auditors, even to the users, and you are learning some sibling denominations. And you know also the distribution of denominations. Pretty much, if you realize that I had 5 and I called it with someone else, he also has 5. Okay, from the number of the denominations, maybe I can pretty much have an estimation of how many users there are. This is used currently from BitMEX, and I think the biggest Swiss exchange at the moment. Another option was, okay, zero knowledge proof is expensive. It's very, very difficult. Let's use SGX enclaves. Let's use CPUs that nobody, even the owner of the CPU, can access this. And in practice, what would happen is all of the computations would happen into a CPU, into a box, and this box will provide an attestation proof that, hey, this algorithm was running here, I'm connecting to a database, and I produce these results. However, we have the problems where some SGX enclaves in the past, actually all of them, they have microcode updates every few months. You don't know if you trust it completely. And in theory, the owner with some very expensive operations, but it is possible in theory to get some access into the privacy of data, extract the private key from the CPU. Even if it didn't happen, it might happen from a big organization one day. And then they can actually fake the results in the future. So the problem when you rely on the CPU is you need to trust all of the company itself, the shipping of the product, all of the logistics and anything until it reaches the destination, plus the actual owner of the CPU. So I mean, I was good with that before we have like fast zero knowledge proofs, but these days, because zero knowledge proofs are fast, we can avoid this, or we can combine it with ZK. And then we had ZK, and this is provisions, the tree version of provisions. And I can explain how it works at the moment. And here we go very deep into the the technology. So here we have again a tree of balances, as I explained before. But instead of showing balances, here, as you can see, I use C1, C2, C3, and C4. Imagine it as a ciphertext. So I encrypt the balance, and I provide the hash again. But I also provide the range proof, a zero knowledge proof of the encryption, that the encryption is not overflowing. This is very important in general. They're called range proofs. This is a particular element of zero knowledge where it proves that a number is inside a range, for example, from 0 to a very big number. And the reason for this is all of the cryptography is operated into groups. Typically, you have modular operations. and you have like the order of the group, the order of the particular mathematics that you're doing. If something is very, very close to the order, let's assume that the order is 2 in the power of 256, and you produce a balance which is 2 in the power of 256 minus 1. If you add something, right, you go directly to the very beginning of the number. This number will be very small now. So you have to ensure that you provide, along with the encryption, some zero knowledge that this is inside some range. And these are the black boxes here, right? And then in practice, you're now having encrypted balances. Nobody can see siblings. Nobody can see the full total, nothing. And you go up to the root, and every time you're doing an addition, again, you provide the range proof, because even the addition might overflow. And then eventually you go up to the total, and let's assume that this group order that I mentioned before is a very big number, like, as I said, 2 in the 256. We assume that the balances are smaller, of course, and then eventually there is no overflow up to the root. So if you don't understand the difference from how we jumped from visible balances into encrypted balances, I can give you some hints if you want to do some digging. Typically, encrypted balances are using a technology called Pedersen commitments. It's like you're putting the balances into some elliptic curves, and then you hide them, and you provide along with them. There is very easy protocols. They are called range proofs. One of the easiest one is bulletproofs that I explained before, and Pedersen commitments are compatible with bulletproofs. And very quickly you can prove if you have an encrypted value, if this value is inside the particular range and it doesn't overflow. This is what you do now, and generally it's considered very easy to be implemented these days, right? It started 5-6 years ago. Now we're mature enough to implement this stuff. So there is still a problem now, however, right? You're still learning the number of people here. Even if you do that, there is some leak, and this number is typically important, especially when you trade some stocks of a particular exchange in the stock market, and you learn this information beforehand, before the official announcement of the company. So something that even the provision authors proposed in this particular case, let's add fake balances, right? So instead of having the users, because now the amounts are encrypted. So what I can do without increasing my liabilities, I add balance 0 as many times as I want, so I can hide the number of the users that I have in my ledger, in my database. However, it's impractical if we have many users, right? And we see some exchanges now having millions of users. Imagine that you have to produce now all of the zero knowledge proofs and everything for these fake accounts. And in practice, if you want to hide the number of users, especially with subsequent proof of solvency, the fake accounts might even require to be a lot more than the user balances. Imagine an exchange starts now, it might have just a few thousand users, but you want to hide this because maybe your audience believes you have millions of users. So you need to add millions of fake accounts just to accommodate this particular hiding. Still, you're not fully hiding this stuff, right? Unless you're putting unlimited fake accounts, but this makes the system impractical. So we optimized provisions in a sense where in various cases, we said first, okay, we have the audit IDs. Here I'm getting a bit more technical, but we created some audit IDs that are reusable between all of the subsequent proof of solvencies. This was one improvement because it's easy now. When you are registering to a particular exchange, you have probably a user ID along with your email. You need your email, by the way. You don't want the company to assign you just an audit ID. And there is a reason for this, and that's why I have a KDF here. Why do we want the user ID and the audit ID? The reason is you never know if the company is reusing the same random unique numbers between two users. And imagine, right? I'm going here, which is easier. If here, for some reason, myself and Jeremy had the same audit ID without the user ID being involved, imagine what would happen, right? If I had 9 Bitcoins and Jeremy had also 9 Bitcoins, they don't need to put both of us here. They can only put one of us here. However, we cannot just have the user ID without an audit ID because someone can do brute forcing of the hash and they can find my email. So we need this information. So we managed to have this reusable ID, and this can be produced like deterministically. Sometimes it's important to produce deterministically, especially if you want to audit the company. How did you produce the audit IDs? And then it's easy with zero knowledge proofs to prove that I cannot sit on the audit IDs. I cannot pick the same audit ID to different users. And then we had another optimizations at the time that like provisions was created. They were using like some custom zero knowledge proofs. Now we have the generic proofs. They're better. Like, as I said, we're using bulletproofs here. They're pretty fast. We managed to have many optimizations, by the way, on the implementation back at Facebook and after while I'm at Misten. And now we have a combined range proof even for all of the path, because here you remember you need to prove. You need to prove here like many range proofs up to the root, right? Imagine, however, if you have a method that can batch transactions and while you are getting your path, you're only producing one range proof that all of the additions that you did were actually correct. There was no overflow in any of the steps. And Bulletproof is offering this batching, and actually you can aggregate them and then eventually verification is super fast. The other thing that we added, is because we have a tree now, we don't need to pad everything with particular fake accounts. We only need to do, after we shuffle the users in the range of the tree, let's assume that this tree could accommodate up to 16 users, and we only have 3 real users, right? In practice, you would need 13 fake accounts. But as you can see here, I don't have 13 fake accounts. I have only the gray one, which are like 6 now. And if you go to the millions, you will realize that it's a lot less than covering all of the leaves at the bottom of the tree. So the trick here was, okay, now that we know what's happening, we can create padding users. Let's see. Yes, we can create padding users just by putting like a padded user when nothing is behind it, right? So we know if on, like after we shuffle them, like on 4, 5, 6, and 7, there was nothing. I'm the exchange. I will create a padding user like in the middle of the tree, as you can see here. And whenever a real user is trying to verify, they will get their siblings. When they reach this node, they will get this gray node, and they don't need to know what's happening below that point. So in practice, you don't know if there are 4 users below this padding node or not. And this actually gives a huge benefit here, right? I can use large trees now, and I don't need to do unlimited padding accounts because now I only need to cover the gaps in the tree. And eventually this means that in particular, the number of padding nodes is at most like 2 times the real users. And I cover like an unlimited range. So nobody can predict how many users exist in the system. Another interesting stuff is we can even use the same technology to do auditor sampling, because previously sampling, I mean, we said that the users can do sampling, but what if an auditor also wants to take a call and actually ask from someone, hey, did you participate in this like proof of solvency? Can you give me something like your balance? And there is a way with the padding nodes that we created when, for example, the auditor doesn't know the users, right? And how many users exist in the system. So they roll a dice, but there is a zero knowledge proof that I will send you the closest neighbor on this dice, in this outcome. And you are convinced that, hey, okay, there is a real user, and with some zero knowledge proof, this is actually the closest one to what I picked. I don't even know. If you hide the tree in the zero knowledge, you don't even know if it was 11 or 8. Imagine with zero knowledge, you can have membership proofs, as we call it, without necessarily revealing the index that you are giving. However, the auditor is happy. Okay, I received like a real user from this tree, and I can go and ask them to do some sampling. So eventually, the final protocol is this. After all of the things that I explained, on the right side, I have some padded to 0 users. Right? Nobody can see this padded to 0 because, as I said, balances are encrypted. You don't know if something is 0 or not. And here we only have 2 users, and the right side doesn't have users. It's only a padded one. So another interesting situation here, I hope I'm not getting too deep, is the following, right? You can have layers now. if we use the same thing for COVID reports, we could have a hospitals creating such Merkle trees from the users, then the hospitals would provide some values to the city, and then the city will report it to the county, and then the county will report it to the country, and then the country will report it to the WHO, to the health organization like the world, the biggest one. So in practice, you can use the same system to actually do composition now of different systems, just because you're using this top level. Something that I forgot to mention here is you don't see the root balance. This is sometimes important. So we also hide how much liabilities you have. And if you also hide how many assets you have, you can even prove that, oh, my liabilities are less than the assets without showing you anything. You only know this is true. And you can even make very small corrections into the system where you fractionally prove that I am at 50% of my balances. And this might be enough, for example, for the regular banking system, not for exchanges, because exchanges are not fully regulated at the moment. That's why we typically require 100% solvency. However, when I asked Deloitte, and Deloitte did this work, as I said, on 2018, like 5 years ago, they were requiring 95% of solvency. And I know I have a monologue here, but I will ask, why? Why Deloitte didn't ask for 100%? I'm asking the audience now. Yeah.
No one can unmute themselves. They don't have the power, but I'm guessing maybe cold wallets, hot wallets. Is that right? Or something different?
The problem is synchronizations of the users. Imagine when you are submitting a transaction, for a while, you don't know if the transaction happened on chain, right? Because typically they have a float account. Every blockchain has a float account. Very quickly, they show you that this happened, but the actual transaction on chain will happen in 1 minute. And sometimes you need, for the UX reasons, you need to very quickly actually update the balances, especially if you are sending from one user to the other internally to the exchange. Sometimes you don't necessarily need to do a blockchain transaction. If both of us are in the same exchange, right? We're only changing the records inside the database of Coinbase. We don't need to make a transaction publicly. But at the time you see the balance is different from the time your receiver is seeing the balance. So they might expect a different balance to be reported for this particular proof of solvency case. And because of this, they said, okay, let's tolerate some money. At least 95% is considered typically safe. There is another reason as well. In many situations, the transactions are in flight and pending because of many things that can happen. For example, you might be KYC'd. There might be situations that they're using layer 2s and the money are locked there. How do you verify these accounts until they go to the L1? And because of all of this, they said, okay, we can tolerate up to 5% insolvency. I hope it was clear. So all of the features here, high total value, high total account, identities, and the population itself. You have another interesting stuff is instead of having the flat version, as for example, the provisions paper, you can trify this thing. And this is useful because if its user is doing their small Merkle path verification, they don't need to verify everything. Nobody needs to verify all of the balances. You're only interested about yourself. So the nice thing is the final element that you see here, new applications outside solvency. And this is important. I will go directly to this one. And here we are. So financial solvency, syndicated loans and insurance. There are situations where some people are putting their money for a particular insured product, but you don't necessarily want to know how much HSBC put there or the Bank of America and so on. You only need to know probably the total or even the total if it's covering the insurance policy that you have. Then you can create all of this stuff and you can prove the inclusion. You can prove all of the information that you need. And the entity that organizes this syndicated loan will report because it's liabilities, right? It's taking money from users. They cannot report a fake amount of money. So you need these Merkle trees with these proofs that I explained. Taxable income. This is where we talked with a government, literally the tax service, the tax authority in this particular government, to use it in order to defend against tax evasion. How? So the whole idea here is the following. It's the tax authorities typically don't have, especially in smaller countries, they don't have the ability to actually do sampling for everyone. But what if you allowed your users, when you are getting a receipt from what you're buying, automatically in the background of tax application you have on the phone, to also do the audit that Amazon, when they reported their revenue, they included my receipt. So in practice, if someone is trying to evade or not reporting everything, you can in theory catch them just because the people who bought from you something, they can actually audit you, and you don't know who is going to audit you. And because of this, it's liabilities for you. And that's why all of this system works for taxable income. So in practice, in this particular situation, in the European, in the European country, was, okay, we don't have the staff to do the random sampling. If we give some incentives to the users to get the receipt, and instead of having necessarily, I mean, some countries are doing lotteries, keep your receipt because you participate with the lottery on this one. I will give you more tickets if you actually do also solvency verification. And this is how you extend as much as you can your staff power, just because the sampling is happening automatically now, but your citizens. The other is credit scores and so on. Imagine you might have in the, like in the leaves, all of the loans that you have as a user, and all of the loans are liabilities to you, right? And they go up to the root. You can prove to someone that this is my total. They can even do random sampling and so on, but you don't reveal necessarily how much you own to this loan, to the other loan, or to JP Morgan. The other thing is fundraising and ICO. I had a personal problem with this in the past. I was like a good nonprofit donor for, especially for nature. I love nature and all of this stuff, but I never knew when I get a ticket or I donate something, if this actually is reported or actually goes where it should go. Imagine you are Greenpeace, you are WWF or any other company, and you are reporting that, hey, I received from all of my users 5 million this month. Can myself, that I just got like a donation of $5, check that, yeah, my $5 have been reported to this total? Because in practice, you might have raised 10 million and you're only saying that you raised 5 million. So if they don't know who is going to check, they have to go through this proof of solvency like mechanism. Now we go to the B situation on the right, voting. Here it was very interesting, and we received this originally as part of a review of our paper, that, oh, there is a good opportunity now to create new applications where the voting process is disapproval voting. Imagine in the US, for example, we have like Republicans and Democrats, and let's assume that there were only, I will make it as simplified as possible, there were only two parties participating in the elections. When someone is voting against like Republicans, in theory, they can cast their vote there. They go to the Republicans database and they say, I vote, I mean, with the anonymity that is offered, I vote against you. But now it's a liability for you. And then eventually you as like the party, you have to report the total disapproval votings that you received. And you cannot necessarily cheat, because if you cheat, someone will say, no, why my vote was not included? So in practice, you can create like a completely different way of having voting, which is called like disapproval voting. In some situations, it might be useful because you don't necessarily need a central entity now to run the elections. You just cast the disapproval votes to the party, and the party has to report it. If they cheat, they're caught and they lose the elections. The other thing is we can use the same thing for rating services and products. Imagine you have Amazon and people are complaining, especially for complaints. What's happening is we can have the number of complaints because there is anonymity sometimes, right? You want your anonymity. You can have the total of complaints, the bad stars or whatever you get as rating. And then people can check, oh, this has like 4.3 as total. Am I included? Is my vote included on this particular situation? It might be liability if it's complaints. So in practice, anything that is liability, have in the back of your mind, can use this system. And now I'm going to the C situation. Here we have the following, right? The government, we covered a bit like the virus outbreak, daily cases. I will mention what we did at Meta. But we also have the unemployment rates and work accidents and many other things happening and published by the government and so on, right? So what's here? Do you agree with that? If you're unemployed, can you check that your case is actually included in the reported total? Because now nobody can check. If they say 1 million people are unemployed, who can check if their case is included? If we had this system, and the same is for work accidents, right? They report the total work accidents, but the total accidents might be more, but you never know if your case was included. You can use the same system. The other thing, I'm going to the D section in the bottom right. You have lottery jackpots. Sometimes you see, I mean, you participate, you probably play slots or something else, and you give something to the total jackpot and you see a counter moving on. How do you know that all of the people are actually participating in the jackpot and the gambling company is not cheating, like a very small amount, but it's cheating? If everyone can check that my contribution is actually involved into the total jackpot, then the system would be by far more fair. And the same thing can happen on like referral programs. There is a situation where websites are sending users to another website by some referral links. And eventually there is no way to check if how many users actually registered and created an account on the other website, right? You're just waiting and you're expecting the other website might be legit enough to give me the correct information. But if your users who were directed from your website to the other website would be able to check the inclusion proofs, then you have someone to help you on this audit, right? Previously, there was not any mechanism. And for these things, there is no auditor. And the ranking system is the same thing as I explained about ratings in the past, again, for ranking if you have disapproval. So these are the situations. And what is the case with COVID? Imagine every day when the pandemic started, we had the report. We tried to actually standardize this approach. It didn't work out back then. There are many reasons why this didn't happen. And with my small mind, I can imagine why this was the case. There was some pushback, especially at the very beginning, because even the countries didn't know if they want to fake the results or not at the very beginning, because it might affect tourism, it might affect business, blah, blah, blah. But in practice, we can be now prepared. We have zero knowledge proof like concepts here. We can be prepared for the future. And one way to do it is with this, right? If we could scan our COVID test, assuming there is a unique number in the COVID test, you're scanned positive, this goes to the hospital or whoever is the organization. And then this report does not reveal any patient data using all of these privacy preserving techniques that I explained. And if you are infected, at the end of the day, you just check that your case is there. And you can even check with your local hospital what the local hospital reported or whatever. And you can find, actually, the government can even use this to track their services because someone is giving you the numbers from behind, like from below. And then you can see if like some particular counties or states are not giving the correct numbers to the final destination, which is the World Health Organization, WHO. So this is how we can use this technology now. You see, we started from solvency, and this is where we are. We can use it everywhere where we need liabilities. I have 4 minutes, and then I will go back to my original slide because this is important. Someone asked me, how many people should check? In the past, even the provisions paper didn't have this function of, okay, I need to visualize this, right? To know exactly, is it a linear equation where if you want to hide 100 people's balance, only 100 people, sorry, everyone should check? No. If you see the functions are actually curved functions. I mean, they go to the bottom very, very quickly. This is the probability of cheating on the y-axis. And on the x-axis is like the percentage of people that should check the proofs. In practice, in this particular situation, we have 1 million users. And the company is trying to cheat to not include one, like the green line, the one on the left, is I'm trying to remove 100 balances from my report. So 100 users are affected, but because you don't know if any of these 100 users in the 1 million will check, because you need only one to report it and then you're doomed, right? They found you, they caught you. You need about like 5% of the people to check. You don't need like all of the people to check. So imagine the probability of cheating now. In 1 million users, you're just sitting on 100 users, which is a very small amount. Like very, very quickly, you can be caught if at least some citizens are good citizens. And even with 100, the story wouldn't change, because typically the one who has a bigger balance has like a better incentive to go and check, right? Because you're affected more if an exchange gets insolvent. So you need this to know exactly, oh, it's not necessarily that bad to use these systems, because only a small proportion of people should check, like 2 to 3%, just to ensure that like the company cannot have a large scale cheating mechanism. We found, by the way, many other issues, and this is where cryptography failed completely. Many used the system that I explained before with very short hashes. I don't know why this is happening, but people are truncating hashes, and in some particular cases, they truncated hashes to 16 bits. Imagine if you are doing the Merkle tree just with 16 bits. This is brute forceable. And we found some of the companies are doing this for efficiency, actually to send smaller proofs. But because of this, they could actually fake the user IDs. They can even fake the amounts. The other thing is many companies use a unique ID, and they don't put the email of something that belongs to the user into the equation, which means that myself and Jeremy could have the same user ID. And in practice, we found it. What was this? It was on CoinFloor, for example. It might be possible to hide at least 5 or 10% from your balances, just because typically users tend to have rounded balances. So it's more probable to own 2 Bitcoins than 1.99, right? Just because you go and buy rounded numbers. And we had many users that actually had the same amount, and actually they didn't move these balances. So it was very easy for the company to reuse the same ID. The other thing is because they didn't use the blockchain, there are different root commitments. They are sending me another Merkle path for another tree. They send to Jeremy another Merkle path for another tree. You need the common place of reference, right? You need the one Merkle root to be published somewhere, and nobody was doing this. In some situations, you can even refresh your page and you would see the proof, but you don't know if I'm seeing the same proof with someone else. And of course, privacy issues almost to everyone. They were leaking the users, individual user liabilities. In my opinion, if someone who was smart back then, they could actually get extra information for proof of solvency before the official announcements, and actually bet on the stocks of a particular exchange before. It's like internal knowledge. And these are all of the affected VASPs, including Binance, where we did a particular audit last year. Current landscape, you will see many papers here. Provisions is something that I recommend for cryptographers at least to start with that, and then they go forward. And the two ones that I was part of it in the bottom right. And I also suggest that you go to Nick Carter. He has a proof of reserves like webpage, and you can see all of the new things that are happening in the proof of solvency, at least all of the exchanges that have proof of solvency and so on. This is the most updated website that I've seen in the space. And I'm done here.
Perfect. Thank you. So I could ask you questions for half an hour. I want to leave time for Jill. I think she has a hard stop at 1. But we will take I'll maybe borrow like 2-3 minutes for questions. So just drop them in the chat. Anyone who has questions, I'll just kick off. So you talked a lot about liabilities. You didn't talk so much about the asset side. One of the challenges, I guess, with zero knowledge is that I guess you could do everything at the circuit level, but if you want to actually prove, like say using snarks, you need the cryptography in the snark to be the same as the cryptography on the blockchain. So you have ECDSA over like a normal elliptic curve, but then you want pairings. And so I don't know if that's a sort of tension that you explored at all, or if you have any ideas about
We did. Let me give you a problem that we faced. A lot of people are using L2s, and in practice, your assets are not even in the L1. The funds are locked in the L2 just because they want to do fast transactions and cheap transactions. And if you're using L2, now you have to add the Bitcoins that are locked in the L2 plus the Bitcoins that are locked in the L1. And imagine if you're using a Lightning network, you don't even know how much balance do you own in the Lightning network unless all of the participants there agree to give you the proof, right? It was very complex to do proof of assets. So it's not only the case of what algorithms you are using on the main layer, it's also where the funds are actually locked, because they are not necessarily locked in the L1. That was one thing. There was also the other thing where there were atomic swaps and people had locked their money in liquidity pools and other situations. And again, these funds, you don't know necessarily if they belong to you because they are locked waiting for a particular trade? Do you own them, or because you have a scheduled order, you don't own them? The other thing on proof of assets was some people never sign a transaction, right? I mean, as you said, we have ECDSA, but you can only see an address. So they have to prove the knowledge of the preimage of the address and then hide it along with all of the addresses on the blockchain to have an identity mixing. And this was not covered by most of the papers. Actually, if I remember correctly, provisions as well didn't cover the situations where the assets are hashed, but you never had the public key of these assets. Some new protocols are using MPC and some other MPC on the head, and some other technologies to accommodate this, but I don't believe they can do in a very, very large scale network. Like if you have many, many millions of accounts, full mixing is more complex. What I realize is possible though, is people can split, like they can create silos of identities, like you are mixing less people together. So I have an account in this particular 1,000 addresses, but you don't know exactly which one. That's the only possible way I can see what will happen in the future, at least to be scalable.
Perfect. Okay, so that's all we have time for. So thank you very much again. And there's one request in the chat for a link to the website.
Yeah, let me copy it from here. It's this
Okay.
one, and actually they have also our papers there and provisions and all of the that you need.
Perfect, awesome. Thanks a lot, Kostas.
Thanks everyone.
All right, we'll move on to our next speaker. Jill, can you unmute yourself and just...
Yes, I can.
Okay, perfect. I can hear you. You can set up your screen while I introduce you. So Jill Gunter is one of the first sort of serious finance people that kind of came across my radar in the blockchain space. She was always on Bloomberg and CNN while crypto was in the media. Maybe that's died down a bit now with the crypto winter. And so most recently, she's a co-founder of Espresso Systems. There's also some equally impressive people involved in that, including some of the people that worked on proof of solvency and bulletproofs that was mentioned in Kostas' talk. A lot of people out of Stanford and the crypto group there. So anyways, I'll turn the floor over to you, Jill, and thank you again for being here.
Amazing. Yeah, thank you so much. What a pleasure to be here. And what a great and hard act to follow with Kostas there. That was really inspiring to hear about such a wide range of use cases for ZK. So we'll be switching gears a little bit here, but hopefully I can make this a coherent segue into talking not just about the variety of use cases that we have in ZK and blockchain in general, but how to actually get those into the hands of users, how to identify who your users are, and how to get them into market. As Jeremy just mentioned, my background was originally in finance. I started my career on Wall Street before falling down the Bitcoin rabbit hole. And I've been down there ever since. I've worked at a variety of startups in the space, doing everything ranging from blockchain for Wall Street, permissioned blockchains, to developer tools, to what I'm doing now, which is working on infrastructure for the Ethereum ecosystem with Espresso Systems. And what I'd love to be able to do in the next hour or so is share some of the lessons, hard-earned lessons that I've had along the way of how to think about communities in crypto, how to think about your users, and again, how to think about building a product to actually get into the hands of users. So without further ado, we'll dive in here. Where I would like to start is with just a general framework of what we're talking about when we talk about product market fit, which is maybe a sort of startup or venture capital buzzword that you've heard, but is widely considered sort of the holy grail of the early stage startup. And it's considered that because product market fit is what happens when you find yourself in a position where you have built something that the market actually wants, that people are pulling out of you, that you can't build fast enough for them. And there are, as you can see, kind of two sides of this, of course. There's the market side, which fittingly is depicted here as kind of the base layers of the pyramid, because the market is the foundation of all of this. And in the market category, you're thinking about who your target customers are, who are the key users who really want the thing that you're building, what are their underserved or unmet needs and desires and wants. All of that is not within your control. The market is not within your control. The market is just there for you to discover. And then at the top of the pyramid here, the things that sort of rest upon those underlying factors of the market is the product, which is very much in your control. That's what you're building. And within the product, you're thinking about the value proposition, the features that you're building, and the user experience. And so a lot of this may be sort of 101 or feel very intuitive to some of you in the audience who have worked as entrepreneurs or built startups. Hopefully, maybe this is new and fresh to others of you. But what I'd like to do, again, over the next hour or so, is run through sort of the process of how one thinks about product market fit, but then more specifically, go into some of the pitfalls that are quite crypto specific that, again, I've learned lessons on along the way. I've observed lots of other people and startups and friends and mentors learn lessons on along the way, and plant some red flags for all of you who are out there working on use cases that you want to get into the hands of users, so that you can hopefully have these pitfalls in mind as you're building. So again, product market fit, this is the holy grail of early stage startups. And it basically feels like this meme on the screen. It's where your customers and your users are basically shouting at you, shut up and take my money. You know, I want the thing that you're building, and you can charge me whatever you want. You know, you cannot build the product fast enough to keep up with the demand. So, you know, the sort of key questions of how you know that you're getting to a place of product market fit is, of course, do you have customers and users in the first place? Are they willing to pay what you need them to pay in order to make this a sustainable enterprise? Is customer and user acquisition happening organically? Are you having to go out and really kind of pull teeth and convince people to try your product? Or are people just finding you, or is it spreading via word of mouth? And then, of course, are you retaining them? Is growth trending to a place where you'll barely be able to keep up? And then critically also, is user feedback more about just tweaks and feature requests as opposed to fundamental product changes? These are all kind of the good key signs that you're hitting a place of product market fit. I've quoted, of course, Andreessen Horowitz down here. Mark Andreessen has sort of some of the seminal blog posts from decades ago on this, but you know what he says is, in a great market, a market with lots of potential customers who are real, the market pulls the product out of the startup, and that's really what it feels like, and you'll know it when you find it. Now, this brings us to our first set of crypto pitfalls here, and we're going to start with the market side of the equation. So the first crypto pitfall that I have done, that I've seen startups do. I also worked as an investor for a period and got to work with a huge cross-section of brilliant startups. But the first crypto pitfall is to forget about the market completely and just get straight to the product. And in my experience, there are a few things that, again, I've done and that I've seen startups in crypto specifically do that result in this. The first category that I want to touch on is the optimizers. And these are the projects that look at something that already exists out there in the market, and they say, well, if we build something just like that, but just make it a little bit faster, a little bit better, give it a little bit better developer experience, whatever it is, then people will really love it. And we'll be able to poach all of the users from that other product. You see this all the time with L1s, L2s, et cetera, of like, we're going to build Ethereum, but sort of XYZ. And that's actually okay. That's a fine place to begin as a premise for a product. But a lot of entrepreneurs and builders, and again, I'll include myself from kind of days gone by in this category, forget to do the research to understand, well, is that really the bottleneck for people? You know, is Ethereum, but just a little bit faster in this one circumstance or in this one way, is that actually going to meet users' needs in a meaningful enough way to bring them over to my own product? And so that's something that you want to think about is just, you know, am I really starting from a place of a problem statement and a value proposition, or am I just optimizing something that already exists? The second category here of the first pitfall that I want to touch on, I call Rube Goldberg 2.0. And of course, Rube Goldberg was this amazing kind of cartoonist and inventor who would come up with these crazy contraptions and devices that, you know, were sort of beautiful and amusing to look at and you know, amazing in their complexity, but we're doing actually very simple tasks that people did not actually need help with. So, you know, here we have an image of the self-operating napkin. Of course, this gentleman could probably much more easily just pick up his napkin and mop up his mouth with it. You know, I'm sure you've seen things like, you know, someone at one end of the room pushes the marble and then a light switch finally goes off 5 minutes later at the other end of the room. I think that it's very easy and tempting in crypto to start just over-engineering these very complex systems out of sort of the intellectual interest of it without actually asking the question, am I solving a problem that needs to be solved with this amount of engineering, this technology? The other example that I think falls in this category that I love, that's a little bit more of a real world example, is that NASA in the 1960s spent an inordinate amount of money developing a space pen, a pen that their astronauts would be able to use in space. And this is a classic example of failing to sort of look at the whole problem space and also look at the solution space and say, is this amount of engineering really needed? Because of course, what did the Soviets do? They did not invent a space pen. They used a pencil. And so again, you know, kind of classic example of getting too excited about the engineering and failing to focus on the problem space and again, the existing solution space. Finally, the third category here amongst the crypto pitfall number one of, you know, forgetting the market are the dogmatists, I call them in crypto. And again, I put myself in this category. I'm very passionate about privacy, decentralization, freedom. You know, a lot of these are the tenets that sort of pulled me into crypto to begin with. But I think it's very easy, again, to, when you're building something, it's a great place to start from to build it for yourself. You know, I care deeply about this. I'm passionate about this. And so I'm going to build this to solve my own problem. But you have to bear in mind, okay, does the rest of the world care about this in the same way that I do? Because it may be the case that there is not a big enough market of fellow dogmatists in your way or your category to actually build a big product and big company around. So any of those paths that I just mentioned will likely lead to years of kind of wandering in this maze, wondering why you don't have product market fit, why people don't want your Rube Goldberg device or, you know, your very kind of specific optimization. And so it's important to step back and bear that in mind. Now, if you've done that, then you can undertake product design research, it's called. And this is the sort of process for finding that holy grail, for finding product market fit. And, you know, you can roughly break this down into sort of an empirical scientific method. You know, you want to do some basic research. You want to conduct some user interviews to understand what the needs are out there. You want to look at comparative products and user behaviors. And then you want to develop a hypothesis. You want to identify personas and the needs and the use cases and have a hypothesis around what the opportunity out there is. Then you want to go out and test that hypothesis. Ideally, you want to do this without blowing all of your money. So you can do this just through prototypes and MVPs, or even just a mock-up, without a back end to it, and conduct one-on-one interviews, focus groups, or best of all, just put the prototype out in the market and start to see how people respond to it. And then it's the process of going back, doing some more research, iterating on what you found. And then finally moving on, of course, to what people think of as product work, which is just usability testing and beyond. But this brings us to our next crypto pitfall, which again is still in this market category, really around underserved needs, which is that as you're conducting product research in crypto, your signals will be inconceivably muddy. It is so hard to get clear signals while you're doing product research in crypto. And there's 3 key reasons I want to highlight for this. One is users in crypto, rightly or wrongly, have become accustomed to the idea that they might get tokens if they use your product. And so, or indeed, they don't even need to necessarily be using your product. They think that they might get tokens if they join your Discord community, or if they follow you on Twitter, or if they tweet about you. And so you might have these moments where you're like, wow, my Discord community for this project has 14,000 people in it. People must really care about what I'm building. Firstly, probably half of those are bots. I hate to say it. But then secondly, a huge majority of those people possibly have joined your Discord because they think they might get a token out of it. Even if you haven't mentioned a token, even if you have, explicitly said you're not going to do an airdrop or something like this. And this extends, again, past even, the sort of Discord community or Twitter follower account. It could be that your testnet product has had 10,000 unique addresses interact with it this month. Well, again, unfortunately, you're going to have to discount that number by some amount, because there are people out there who spend their whole day just generating unique addresses to interact with testnet products in hope that they might see some tokens out of it. So it's just incredibly muddy. I talk to my friends who are entrepreneurs in other industries about this. They're like, how do you ever sift through this? And we'll talk in a minute about some of the tactics that you can use to try to discount this and to try to think through it. The second category, and I was a venture capitalist myself, so I feel I can say this, is discounting to a degree venture capitalist feedback, because venture capitalists are not necessarily your users. And so it can be very tempting and very exciting to say, oh, wow, I'm building this ZK proof of reserves product, and all of these venture capitalists want to talk to me, or even all of these venture capitalists want to give me money for it. That must be a great sign that I'm onto something. And it is, to a degree. Venture capitalists are smart, they're paying attention to the market, and that signal is worth something, but they are not your users. And so until you have identified those key users and gotten the positive feedback from them, until you have your users wanting to talk to you and wanting to give you money, continue to discount that. And then finally, coming back to the dogmatist category, you could even have a strong core group of your fellow dogmatists pulling that product out of you, giving you that signal of product market fit. But it might be sort of like a dozen people, scattered around the world. And that is probably not going to be enough to find a really meaningful market around. And so you also want to make sure that you're not using a very small sample size to extrapolate to say, okay, this is a big enough market to make this viable. And so it really comes down to this question of, are you my customer? Not are you the airdrop farmer? Are you the venture capitalist? Are you sort of my fellow ideologue in whatever way that it is? You've got to be very, very careful in your methodology and your interpretation of product research. But okay, so let's say you've done all of this, and congratulations, you've got a prototype, you've gotten good feedback on it, you've discounted all of those metrics because of the dynamics that we just talked about, and now you have a product that you can put in the market, productionized, but you're still not quite there in terms of feeling that pull of product market fit. This is where stated versus revealed preferences come in. because you may have done all of that research. You may have gotten a lot of indications from talking to users, from spending time with them, from being a user yourself, from people saying, yes, I really want what you're building, and this meets a need that I have. But it turns out that their revealed preferences may be very different. I've experienced this specifically, and this maybe kind of puts me in the dogmatist category, but just to share, with privacy. Privacy is something that people will always say, yeah, I care deeply about my data privacy. I don't want everyone to see what I'm doing. And then you put a product in front of them, and the second they have to start making some user experience trade-offs and things like this, they'll say, oh, can I just go back to what I'm comfortable with, actually, even if it's not private? So this is where you really begin to test your value prop. And this really comes down to just being a matter of listening to your users and going back to iterate again. But this does also bring us to our third crypto pitfall, which is mistaking speculators for users. And so on the flip side of this, you may put the product in market and it may go gangbusters, and you may be saying, wow, I can't even keep up with demand. We've got to scale the back end of this. You know, this is crazy how many people are coming on board and using this. Well, those people may be users, and I hope for your sake that they are, but in crypto, they may also be speculators. So, you know, these are the types of things that you would hear each person in this category saying and posting on Twitter and posting in your Discord channel and so forth. You know, this is classic. I actually Googled, or I searched on Twitter last night, very good project, ATH, all-time high. And you would not believe the number of hits that just that search term brought up for various projects, some big, some small, within the crypto space. So this idea that people are out there saying, yes, this is a very good project. It's backed by great investors. It's a good team. I'm buying in. Soon it will hit an all-time high. These are the people who are just trying to participate in a pump and dump. They're buying into your tokens. They're saying things like this publicly, trying to get the token price to go higher. And then they're planning to exit or dump those tokens as soon as they get that pump that they're looking for. Then you also have the bag holders, and this is usually after the pumpers have come and gone within a project. And heartbreakingly, the bag holders might be your actual users. But if you have a token involved or anything of the sort, then they may convert from being actual users into just sort of frustrated, beleaguered people who care more about the token price going back up to what it was when they started using the product than they care about the product itself. And so, you know, you'll see these people in the Discord channels of crypto projects saying things like, well, there's still no movement on the price today, but soon it'll go to the moon again. You know, I'm just waiting for that one last pump. And then finally, the third category, and this goes for a lot of the DeFi projects of the last few years that had these incredible sort of sticker APYs that they would be offering in terms of yield of, you know, 18,000% annualized yield from using this application. Of course, that yield was coming in the form of the tokens that the product was issuing. So slightly questionable in terms of displaying the value proposition up front there. But you'd have people who would come in and sort of as mercenaries use this DeFi product for however long they could juice that yield for and then exit. Again, I would argue none of these are users. These are speculators around your product. And this is basically what that feels like. If your users, quote unquote, are more interested in the money, if they're like Tom Cruise here shouting, show me the money, rather than talking about the actual utility that they're getting out of your product, those are not your users. Those are speculators. And, you know, I don't want to sort of overstate the pitfalls of having a token associated with your product. If you do it sort of within regulatory and legal frameworks, which are constantly changing, disclaimer, I think that tokens can be these really powerful and necessary incentive mechanisms within crypto products. But they do come along with these pitfalls. And again, I've seen too many great projects think that they've found product market fit as soon as they put something in market. But in fact, those were just their speculators, and unfortunately, very short-lived. But okay, so let's say though, you've got your product, you've done your product research, you've got your product in market, you've found some actual users, not just speculators, and now you finally reached that top of the pyramid, the sort of Maslow's hierarchy of product market fit that we keep pulling up here. You're finally at the point where you get to bring the value proposition of your product to life. Which hopefully doesn't feel quite like this Frankenstein image, but may at times. This is really now about refining the user experience and the features within the product. This is the part actually that most people usually think of as product work. It's funny, sometimes when I tell people that I'm working on the product side of the startup, they assume that I'm like a UX designer or something of the sort. No, it's mostly the other elements of this that I just covered. But the user experience and the features, these are the things that should all be defined by all of the data that you've gathered on your target users, on their unmet needs, on the value proposition that you can offer them, not the other way around. I think that too often startups in general, this is not crypto specific, get really excited about feature sets and user experience towards the beginning of the process and fail to have those be a result of the data and the insights and the value proposition. One thing to note here is that a user experience fix or a single feature, that's not going to get you to product market fit. I think that this is a fallacy, again, that startups tend to fall into, where they say, oh, once we ship this one feature, then that's when we're going to find our user base. And I think that that's usually misguided. It usually comes back to needing to revisit the fundamental value proposition that you're starting with. But however, failing on the user experience and the feature sets, that can still totally break your success. And I want to dive in here to crypto pitfall number 4, which is very much a user experience and features issue and touches on the ways in which failing on user experience and features will fail your product as a whole. So one of the first ones that I see all the time is you open one of these Web3 applications, whether it's something like a decentralized exchange like Uniswap, whether it's like a crypto social network like Lens or Farcaster, one of these things, and the first prompt you get is connect your wallet. And that might seem fairly intuitive, but as someone who's been in crypto as a user for many, many years, and also as someone who's sat on the other side of countless user interviews for these types of applications, I can tell you that experienced crypto users are going to be very skeptical of connecting their wallets to any kind of new product. And so when you greet users with connect your wallet and you're a brand new product, no one's really heard of you, maybe they heard of you by word of mouth or they came across you on Twitter, they're going to be like, I don't know what this is. I don't feel great about this. Let me just go see if anyone else I know is using this. Let me go do some research and I'll revisit this at some point. Of course, in kind of traditional startup world, this is called churn. You've gotten the user to the point where they're thinking about using your product and then they churn away from it because of the way that you've greeted them. The next thing, usually once they've connected their wallet, at least if it's a DeFi product or any kind of financial application, which of course there are many in crypto, including NFTs and all of these things, then the next step is usually deposit funds. Lovely. You can see where the issue is here, because relatedly, users are rightly going to be so wary of depositing too much in the way of funds into a new protocol or product, and that's going to create all of these headwinds around your traction and growth. But also, more importantly on this, you as the developer of the product are also going to be burdened with huge responsibility. And so you yourself are probably going to have to rate limit your own traction and growth. Most products in the DeFi world, or indeed like layer 2 projects, other infrastructure projects that are asking users to deposit funds, they will rate limit or cap the amount of funds that a given wallet can deposit up front. And this has become kind of a best practice of just sort of responsible building and responsible go-to-market, while the thing is still being kind of battle tested out in the wild. And then finally, again, I sound like a huge token hater here. I'm not. I think tokens are extremely powerful. But the third sort of hurdle of building and keeping trust around the user experience of your crypto product comes down again to the buy this token prompt. Again, tokens are very powerful. They're very powerful incentive mechanisms, but they also create friction. And people out there, they're worried about getting rug pulled on the token. They're worried about the pump and dump. They're worried that the token is not sort of legitimately needed within the product. They're worried that the value is not going to accrue to the token. It's going to accrue elsewhere. And then there's also just the very practical friction of having to buy a token. I've got to get money into the system. I've got to find the on and off ramp. I've got to find a place to buy it. Who is that money going to? What is the team doing with it? All of these questions arise. And so just introduce tokens with great care. So yeah, this is pretty much what it feels like to work on crypto UX is more or less like walking into Mordor. One does not simply acquire crypto users, because we live in this industry of hacks and exploits and rug pulls and pump and dumps and phishing and impersonations and you name it. There's such adversarial dynamics going on surrounding the crypto market, the crypto industry, and therefore your crypto product. And so, a few rules of thumb here. One, I would say very important to offer value ideally, but at least sort of a hint of what the product is going to be before asking users to connect their wallets. Make sure that the first thing that you're asking of users is not, oh, connect your wallet here, but instead showing them, what does the interface of this look like? What will they be able to do if they connect their wallet? Are there things that they can do without even connecting their wallet? All of those are good places to begin. Then secondly, make sure, especially if you're taking users' funds into your product, that you're balancing the responsibility and risk aversion that you should have that are going to be very healthy with the growth seeking that you have to do, of course, as an entrepreneur. And so again, things like deposit caps come into play here, and it's just a tightrope that we all have to walk. And then finally, again, just require tokens with great care. So congratulations, you have developed, researched, built the product, put it in market, found some real users around it. In almost all cases, though, this is not a one-time process. This is the process of product building, company building. You're going to have to constantly revisit your assumptions about your target users, about what their needs are. Their needs are going to be constantly changing, especially in such a nascent emerging market like crypto. Things are constantly changing. Therefore, you're going to have to be constantly adjusting the value proposition that you're offering, and then, of course, how you package it up in the UX of the product itself. And the beauty of it is that because these things are constantly changing, it means that we're constantly, as an industry, making breakthroughs in terms of best practices. I think it also means that as an industry, because we're so nascent and so sort of at the beginning of our life cycle, there's also a lot of sort of forgiveness of flubs or making mistakes along the way. There's a lot of opportunity to just keep iterating. elsewhere, sometimes you'll need to respond to major market shifts, new competitors coming in, regulation coming in, again, the evolution of your users. And then other times it will just be about much smaller tweaks and refinements. And that, of course, is always a nice place to be. But it's a rare place to be in crypto, which brings us to kind of our final crypto pitfall here. We'll put it all together. And I've titled this When to Pivot and When to Persist. And I think that this is perhaps the most important consideration for anyone who's working on a use case and working on getting that into market. So pivoting generally refers to when you're building a company, you realize you're not going to find product market fit in a given direction, but you have an inkling that maybe over here you will. So you pivot your company in that direction. And then, of course, persisting is when you have the strong vision and you want to stay true to that, even in the face of some adversity. And some of the adversity that may arise specifically within the crypto markets are the following. So firstly, bull and bear markets. A lot of the ideas that look great in a bull market, look pretty bad when the tide goes out, either on the macro level of, oh, no one's interested in crypto or no one wants to be sort of speculating on these things anymore. Or indeed within a specific trend. There have been moments where it looked like NFTs were going to rule the world. And, the crypto bull market maybe was even still persisting, but the tide went out on NFTs. And suddenly all of these NFT startups had to kind of scratch their heads and look around and say, do we really believe in what we're building? Do we think that this market is going to come back or be here to stay, or do we need to pivot? Similarly, there's a sort of running joke now amongst crypto startups and venture capitalists about crypto startups pivoting to do AI, because of course AI is sort of the hot topic du jour. So, all of these crypto startups that got started a couple of years ago when crypto was at the peak of its hype cycle, are they all doing, generative machine learning now? In my experience, actually, no, many of them are persisting, which I'm very glad to see. But, the lesson here is not, you should pivot when the bull market becomes a bear market or vice versa. I think actually very often persisting is the right thing to do. And I'll get to that on the next slide. But being mindful of this and being thoughtful about it, and also planning ahead. If you're starting an NFT startup at the peak of the NFT hype, you need to be prepared for that hype to go away. And you need to have a game plan for how you're going to find your users, how you're going to develop a sustainable model, even in the absence of that. Secondly, regulation. Regulation in crypto is this global, evolving, super uncertain dynamic. And I want to be clear, it can create opportunities. There are plenty of startups in the crypto space that have seen these regulations within crypto arising and moved in to accommodate them, or indeed to sort of enable or empower, the consumer protection or whatever that's being mandated by regulators. Companies in that category that come to mind, a couple of them are things like TokenSoft or CoinList, which very much grew out of not perhaps regulation specifically, but certainly a lot of the scrutiny around the ICO boom of 2017, when everyone and their brother was issuing some kind of token. And there was a lot of scrutiny, both in places like Washington, D.C., but also just amongst sort of the mainstream of like, what are these things? Are these legitimate? Are these securities? And again, we had great companies arise to kind of fill that need and say, okay, there's a way to do this. There's a way to do it right. Let us facilitate that. So regulation does not need to be this big, scary, negative thing. Again, in a way, it can prompt a lot of great innovation, but it is this fairly uncertain dynamic. I think another great example of this was Costas was talking in the last presentation about proof of reserves. And we've seen a lot of great sort of uptick in interest in proof of reserves since the FTX debacle and a lot of the issues that happened last year. And I think that that's another great example where, of course, there's been regulatory scrutiny around crypto, thanks in part to the debacle of FTX and others. But I think that, in a way, at times, that kind of scrutiny and regulation can be indeed the mother of invention. And so that's, I hope, a more kind of hopeful take on regulation. But then finally, talking of those debacles of last year, things like contagion, things like what happened with FTX and others where the reserves just weren't there, things like hacks. Very often I'll see crypto startups sort of see one of their competitors get hacked or have one of these types of issues, and they'll be like, oh, this is our opportunity to move in. We can take market share from that competitor. This is a great moment for us, but not so fast, because the more likely outcome of that is that the whole market that you were targeting is now spooked, right? We saw this happen with products like BlockFi and Celsius and others, and these sort of crypto lenders, centralized crypto lenders that all tended to collapse last year. It sort of looked like there was going to be this moment of consolidation where users would all migrate from the ones that were failing to the healthy ones. But in fact, what happened is that whole user base pretty much disappeared over the course of a couple of weeks, because everyone just said, this is not worth it. I'm not touching this with a 10-foot pole. Show me the money was good for a while, but I'm going home now. I'm taking my winnings and going home. And so, this is another moment where, again, if this happens within the space that you're building, maybe not even specifically to you, hopefully not, but if this happens within the space that you're building, this is another one of those key moments of, well, do we believe in this market? Do we believe this will come back, or do we pivot? And what I want to touch on here is I think actually like quite a hopeful and inspiring story. This really stuck with me. This was from a newsletter that the Paradigm folks, an investment fund, put out a couple of years ago. And this is really about when to pivot and when to persist. And so one of the folks at Paradigm was one of the co-founders of Coinbase, Fred Ursum, and he shares this story, which is that in one of the first kind of really big down cycles within crypto, it was 2015, and so Bitcoin had gone up to like $1,000 in late 2013, early 2014. Mt. Gox had happened. There was kind of a whole series of terrible things, bad press about crypto. A whole lot of users got really hurt in the process. And suddenly Coinbase went from being a bit of a darling in sort of early 2014 to being viewed, at least, as being kind of lost in the woods of, oh my gosh, these people are still working on this Bitcoin exchange thing. And he shares that in 2015, a Coinbase board member suggested that they start working on private blockchains for banks because it offered a short-term cash opportunity. And this was indeed, I was working on this stuff at the time. This was indeed the days when, all of these banks were kind of starting to poke around and look at blockchains. And the catchphrase was blockchain, not Bitcoin. The Bitcoin thing is very sketchy and scary, but if we can have like a private blockchain, permissioned blockchain, and have that replace our internal databases at banks, then that's going to be very exciting. And so I can only imagine what it was like to be sitting there, as one of the Coinbase founders at that stage, having a board member, someone you deeply respect, say to you, look, it's time to give up the ghost. This Bitcoin exchange thing is not working. There's all this demand over here. Go chase that. From the big banks. And, of course, he shares here, it's a pivot that they're in fact glad that they avoided because it was going to be off mission and temporary. And of course, Coinbase is now a publicly traded company competing with those banks. So it's not, these lessons of the bull and bear markets, the regulation, hacks, contagion. It's not just about, be ready to pivot. it's also about knowing when to persist through that. So putting this all together, just to summarize here, product market fit is a well-studied, well-talked about thing within startup building. Dan Olson is the one who I stole this pyramid from. There are a lot of great books out there if you're interested in this topic within startups in general. But my goal for today really was to share the kind of key crypto-specific lessons that, again, I've learned along the way of the things that you need to consider when you're searching for product market fit within crypto. And the first, of course, is to start with the market, not with the product. Don't go be Rube Goldberg out there. Know what's a signal and what is not as you conduct your product research. Airdrop farmers, those are not signals. Relatedly, don't confuse your speculators with your users. Treat tokens with the caution they deserve. Building and keeping trust is necessary, but also not sufficient to get your product to succeed. Remember the lesson about connect your wallet. Don't ask users to do that right off the bat. They will be skeptical. And then finally, be ready to think about and be ready to know when to pivot and when to persist as you face all of these idiosyncrasies of the crypto market. And finally here, I also want to end on a little bit more of a positive note. It's not all pitfalls in crypto. There's a lot of amazing things about building and bringing products to market in crypto. I know that we just heard earlier, and you'll hear more over the course of today, and you heard more yesterday about all of the amazing new use cases, of course, that are out there in crypto, all of these previously impossible applications that are ripe to be brought to market and meet unmet user needs. There's all kinds of amazing things that you can do in crypto around incentive design, growth flywheels. An incredible dynamic of crypto is it's a totally global market, pretty much. If you're building a financial technology application in the United States that's not crypto, you're limited to the US market. If you think of Venmo or Robinhood, they're totally limited to the US market. But if you're building a Coinbase, you can go global. If you're building a Uniswap, you can go global. And so I think that that's something that's oft overlooked as a real opportunity. You can get real-time on-chain user insights. You can learn a lot about your users, given the transparent nature of most blockchains. It's a high growth market. There's all of this just open innovation happening. So it's not all bad out there, but I do hope that some of what we've covered today will be helpful to some of you as you consider the pitfalls as well of going to market within crypto. And I think I've actually ended early. So if there are questions, I would love to chat through that. I'm happy to share more about my own personal experiences, and then also just what I've seen kind of along the way of all of these, again, hard-earned lessons on my part.
Awesome. Thank you so much. That was, it's a talk that everyone should watch before they start business in the crypto space. Anyone who has questions, drop them in the chat and I'll read them off. Or if you want to just ask directly, just say, can you unmute me, and I'll do that. So I'm an academic, as you know. Some of us are academics, some of us are from industry, and your categories of Rube Goldberg, dogmatists and optimizers. Yeah. That totally fits academia, right? So we see new papers, and those are the three kinds of papers that nobody likes, that usually get rejected from conferences in the end. But anyways, it's good to hear that that in academia those things are not necessarily welcomed with open arms either, because I think that I do think that there can be some value in building a Rube Goldberg device. It's just not the value that is sort of going to lead to probably either an academic breakthrough or indeed a great company. Yeah, exactly. Or you mentioned the VC stamp of approval, but for us it would be I got a big funding from some agency, and but my research never gets cited. No one cares about it, but I got millions of dollars or whatever.
Yeah, that's spot on. I love that.
Okay,
I work, as you mentioned, I work with a lot of former
Right.
academics, and I'm sure that they would appreciate that parallel too.
Yeah, actually about that. So how do you sort of like within espresso systems or whatever, how do you like go and look at academic research and say, oh, that's actually a good idea that could cross over, like there's a market for that idea. It's not just a sort of, crazy academic idea.
Yeah, yeah. Well, I mean, I would say that it starts primarily with just market research. And so trying to look carefully at what the problems are out there. And then really trying to parse whether the things that people kind of are talking about as problems or thinking of as problems are indeed the blockers. And I think that scaling is a great example of this, actually. And this again comes back also to the stated versus revealed preferences of people, right? Is that, people in crypto and blockchains lose their minds about scaling. There's a whole period a couple of years ago, and I think we're about to re-enter such a period where all anyone could talk about was all of these new L1 protocols and what the throughput and the TPS was for each of them, totally disregarding the fact that it also depends on what kind of transaction you're submitting and what kind of interaction or smart contract call you're making, whatever. But if you actually look at it, I think that people are right that in the long run, scaling matters deeply. And I think that the place that we were at with scaling, even but a few years ago, was obviously unacceptable, where people were having to pay, hundreds of dollars for an NFT drop, or, to buy a crypto kitty or things like this. That's not going to work. But I think that this is something that we've tried to think very carefully about, within Espresso, and also talk about, is that it's not enough to just go in and say, okay, well, if they can do 140,000 transactions per second, we're going to win by doing 150,000 transactions per second. It's not enough to just be applying sort of research breakthroughs. Again, that might be a nice to have, and that might be on some level necessary, but it's certainly not sufficient in terms of winning over users and customers, especially when you're getting into the more kind of marginal gains that you're making in any given area. And I think that in my own experience, this is a place where it can be very tempting for those coming from the academic community to say, no, but this is a meaningful breakthrough. This is going to be those extra 10,000 transactions per second or whatever. And maybe it's partly the mindset of like, that was good enough to get me published, so this must be something that people care about. And again, it might be something people care about, but it also is probably not going to be enough. We've seen this, right, with the battles between Ethereum and Solana and Aptos now and other L1s, where those other L1s, I think I have tremendous respect for, and they've done a great job, but it's still not sufficient to be an Ethereum killer, which, is sort of, I don't think any of those projects really cast themselves as that, but certainly the market tried to cast them as, oh, they're going to be an Ethereum killer. No, people would still rather use Ethereum because of the community around it, the developer experience around it, because they're used to that, because there's all of these courses and tools out there for programming and Solidity. It's where all of the users and liquidity are. And so it's not enough to just say, we're going to apply this breakthrough and we're going to scale in this better way. But it's hard. Like, it's always very tempting to say, oh, if we just apply this breakthrough, then we'll have the better product and we'll win.
Yeah. You have to move to where the value is too, I guess. And that for me is like the main thing that keeps Ethereum going. I guess with layer twos, I was going to ask you one question, then someone has their hand up, and there's one in the chat. Do you think token drops could actually embitter users? So I had a flash where we were very early users of Arbitrum. Love the project. One of my students is on the call, Deedham, and she was like, implementing things on test nets that don't even exist anymore. Like the links are completely dead kind of thing. And so, I got some airdrop tokens, but, for a Flash, I love the project. I want them to succeed, but I was like, oh, maybe I should have got some more. Like I see all these other people and, they were hanging out on Discord or whatever, and they got like 10 times as much type of thing. And so, also like, for me, it was like, I guess because Optimism did it first, I thought, oh, that's just a huge distraction. Like they're not going to focus on the infrastructure because they're going to be managing this like token now. And
it is a huge distraction for the project.
Yeah. So
I think Optimism has done it actually really quite well, but I can tell you from having been on the inside of projects like this, it is a huge distraction. And I think that that's spot on. I do think that they end up embittering a lot of users. And I think that there's been a lot of different experiments, which I've really welcomed, that have been run over the last year or so, specifically in terms of trying to make airdrops better and trying to make sure that they're not just rewarding the people who are kind of hanging out, making a lot of noise, whether it's in Discord or whether it's on chain, just doing activity for activity's sake and really trying to identify who the valuable users are, who maybe, they do want to have as actual stakeholders within the ecosystem. I think that other ways, but I mean, that's sort of an identity and sort of Sybil resistance problem that feels slightly intractable to me. Hopefully not forever. I'm sure that there's some much smarter people than I am on this and in the audience who are maybe even thinking about this, but I think that's a huge problem space for the industry. And I think that again, this comes back to like the proceed with caution with tokens, is that even just that sort of bitterness or infighting or what have you, I think can create a huge distraction for the project as a whole. I'll give a counter example though, just to show that there is some hope, is that the Solana folks, and this was less like an airdrop situation. It was more just like the circumstances in which they launched their token. They launched in March of 2020, which was like, everything was in turmoil. It was sort of just the beginning of COVID. The broader financial market was down like 30% in a week. I think crypto must have been down like 50% or something like this. And God love them. They were just like, we're ready. We're putting our token out there. And so all of their grant recipients and all of the people who they were kind of bringing into the ecosystem got these tokens at, like, as it turned out, like bargain basement levels. And I think that, to the Solana team's credit, like they were very brave to go out and do that in that way. And I think that really served them well, as it turned out, in terms of bringing a lot of people kind of along for the ride, of what then turned out to be sort of Solana summer. So there are ways that it can go really well, whether those are architected or not, but certainly a lot of chances to create bitterness as well, like you say.
Perfect. Okay, I want to be mindful of the time. I think you have a Twitter space starting.
I do, yeah. I'm gonna have to run in a minute.
So Costa has a question in the chat about ranking. I believe the slide that's there.
Yes.
And Gregory has his hand raised. Gregory, why don't you just shoot off and you can maybe think about the ranking while he asks his question.
Yeah, perfect.
Okay, thank you. Yeah, it's a very interesting presentation, very practical, great examples. My responses are partly semantic, theoretical, about a term that came up a few times in your presentation. I think the word arising in terms of market doesn't need to reduce to evolving. And the terms intentionality and agentiality, that's more like a human social sciences than a natural sciences. And that gets to scaling, because intentionality and agentiality, we need that. I'm sure we agree for scaling. There happens to be a uniquely Canadian alternative to this language. You said the evolution of users, or user evolution, or regulation is evolving. Russell Belk at York University in 1988, he came up, it was called Extended Self in the Journal of Consumer Research, their most cited article. And this seems to work better and with the blockchain language as well as with the tokens than this kind of evolutionary language. It's more like, direct and active. And then it also connects with Marshall McLuhan, and that can be applied to distributed ledgers, because McLuhan in 64 with his extensions of humankind So we could say users extend, they don't evolve, or we don't evolve. And that gets over reducing us to these automatons that are being marketed to. So then that changes the definition of money when we extended the digital world. That's the article that Belk wrote in 2013. So I think that language fits.
This is why I love working with academics and presenting to academics, is because there's all of this like sort of rich background that I would never know about, and that can greatly refine this. I love that.
Thank you for this.
Yeah. Please share those references in the chat. I would love to follow up on them. Thank you.
And then
And
Costas,
yeah,
was
just
asking what you think
briefly to
about
close
this.
us out, Costas' question. I think that the one that I would probably start with, and this is not to say it's necessarily the most important because I think that's context dependent, but the one that I see crypto startups just mess up all the time and that I think is most mind-blowing to people not in crypto are lessons 2 and lessons 3 around being confused about who's a speculator and who's a user. So I would probably rank that as number 1. And I think that, you know, for us as entrepreneurs, too often we just follow the speculators, and that leads us into these really unhealthy places as an industry, as companies, as builders, where you know, we kind of set ourselves up for these like crazy bull and bear market runs because we are just serving speculators who are going to be easy come, easy go. So in terms of, you know, changing that narrative, I would say pay attention to 2 and 3, and then yeah, the rest will come. But
Great.
hope this was helpful. It was certainly fun for
comment,
me. Yeah.
Asking to connect to websites. I think that resonated with a lot of us. The website, like first asking, like connect your wallet.
Yes. Yeah. Absolutely.
Everyone sketched it, but anyways.
Absolutely.
So
Well,
thank you very much for being here. I'll give you a virtual round of applause because no one can unmute themselves. But yeah, thank you.
Thank you all. Have a great rest of the day. Take care.
Thanks. Okay, so next we'll move on to Joni Brennan. Do you want to try and unmute yourself, Joni, and try and share your screen if you can, just to make sure it works. I'll introduce you while we do.
Yeah, thanks a lot.
Okay, so Joni's president at DIAC. So this is Digital Identity and Authentication Council of Canada. And she's going to talk about digital identity, obviously.
Perfect. Thanks so much. And while I'm making sure I'm set up properly here, I also wanted to say what a great talk just in advance. So really great talk, Jill. Thanks so much. And I love the tie-in to the lessons at the end, and starting with your market, and not starting with your product. I feel like those maybe it was 5, those lessons that were shared were just absolutely fantastic and on point for what we're going to talk about now, which is all about Canadian perspectives on the topic of digital identity and how we can work together, and some tools for building public trust in this ecosystem. So I'm Joni Brennan, president of the DIAC. I'm coming to you from Vancouver, British Columbia, and I'm really thrilled to be with this group today. So let's get into it. If you don't know who we are as DIAC, we'll go through a bit of who we are. We'll share our digital identity research insights from 2022. So this is 2022 data. Excuse me, I'm getting over a cold. We'll also note that we'll talk a little bit about de-risking adoption and what that means, and some of the tools that we're offering to work together to move the space forward. So let's get into it. So if you don't know who we are as DIAC, we've been in operation for more than 10 years now. We are an adoption accelerator. So we develop white papers, projects, research that helps to inform strategy and tactics regarding digital trust and identity, and helps to reduce uncertainty within the space. And then we're also a trust framework provider. And so what that means is we're an organization that develops a risk management framework, and then we verify compliance of solutions and services against that risk management framework. So that's a little bit of who we are, and in terms of our leadership, just a quick view at the organizations that are sitting on our board, and we're about 100 member or so organization. So we love to collaborate. So if you want to collaborate or are interested in what we talk about today, please get in touch. So in the context of starting with your market and understanding what your market is looking for, we've done our digital identity research for 4 years now. This is our 4th year of the research, and that research has been conducted through a third-party a research body that helps us, that's delivered a survey. I think it's been 3,000 Canadians coast to coast to coast that we've been asking, that we've been providing these questions to for 4 years. And also we have questions that we've asked each year. So we've got overtime trends, and then we also have point in time questions that we ask depending on kind of what's happened in that year, what's transpired. So just to give you a concept of the methodology. So as we begin, if we're looking at 2022 data and comparative to 2021, we have actually seen an uptick of Canadians who stated that they were willing to share their personal information if it made their online experience more convenient. So slight uptick from 75 to 78%. And then it is kind of a paradoxical space. And the reason I say it's paradoxical is because while the willingness to share the personal information to make their lives more convenient has gone up, at the same time, pretty consistent, 75% to 73% over the course of a few years, there is also equally high concern about their information being compromised. So, people are kind of at par in terms of their willingness to share and their information being compromised. So it's a bit of a, perspectives are paradoxical on this front. And I'd say that that's been consistent over the last 4 years. And so that's something we can know about our audience and their willingness to share personal information. Now this year, I think we had some good news. We've asked year over year for people to tell us their familiarity with the concept of digital ID, what they think it is. And for the first 3 years, we were not able to get above 50% responding that they were extremely or somewhat familiar with the concept of digital ID and what it is. And in 2022, for the first year, we actually see over 50%, so 52%, saying that they're extremely or somewhat familiar with the concept. So this is unassisted and being able to produce they feel that they can produce a kind of a definition. So there is that knowledge space is growing, and that perspective is growing on what we're even talking about. In general, though, I can say digital identity, the words digital ID out in the public, it has been very confusing for people. So there's been some growth there. Also, the respondents that reported being very interested to learn somewhat interested to learning more about what digital identity is. So that's gone up as well. So from 69% to 72%. So knowledge has raised, as well as the desire to learn more about what the topic is. And so I think these are all, positive signals that that knowledge is growing as to what a kind of a confusing space has been out in the public, which may include practitioners and non-practitioners in the space as well. Now, also in the positive note, of the respondents of the survey, 55% felt that digital identity has a positive impact on their lives. We'll talk a bit more about what that positive impact is as we go forward. But I think it's great to see that more than half are feeling that their concept of digital identity, those tools, those capabilities is improving, and can improve their life in a positive way. That said, 23% remain unsure about what the impacts are. So when we look forward to education and the part of the group and the public where we may need to spend some of the most impactful and efficient time with, I'd put forward that it's this 23% who are unsure. So This is a place where we'll target for education in the public space. And then, of course, the remainder felt that it had a negative impact in their lives. We certainly want to do some education, better understand those negative impacts. So those are areas that we'll continue to work to raise that knowledge base and education and understanding in the public. Now, in terms of some of those benefits, the group that felt most, the demographics group that was felt the most opportunity for digital identity to help them in their lives were what we call the parents and senior caretakers, the caregivers. So these are the people who they may be caring for children or dependents in the home, seniors in the home or seniors not in the home. This is thinking about things like tracking health records, school, government registrations, all of that data that needs to be managed in a safe and secure and privacy respecting way. And these caregivers, these caretakers, who often do have to care for dependents and those within their family and friends on both ends of their lives, up and down. They feel the most benefit, and they also need to take care of their own data at the same time. So there's a lot of pressure for those individuals specifically, and they're the most interested in moving forward with tools that can help them around this kind of data management. Now, when it comes to Canadian perspectives on the effect of the COVID-19 pandemic on the relevance of digital identity that's secure and trusted and private to help people transact more safely online, it stayed relatively flat, 2/3, 66%, 67%. So COVID-19, definitely the need to social distance and work remotely, work from home, all of these and more were drivers to why raising awareness on the benefits of digital identity that's secure and trusted and private for those needs. Now, looking a little bit more into particular methodologies, and I think particular for this crowd as well, is the familiarity of the concept of the digital wallet. The concept of the digital wallet, what it is, respondents reporting that they were familiar with this concept grew from 54 to 59%. So this has absolutely grown in the course of the last year. And then this year, only 14% that said that they were totally unfamiliar with what a digital wallet was, compared to 21%. So that makes sense. Familiarity's gone up. Complete unfamiliarity has gone down. So people are starting to understand digital wallets, what they are and what they can do. And in terms of that specific use of our respondents around digital wallets, the reported use of those digital wallets went up a little bit, from 38% to 41% of those who reported using digital wallets. Of that usage, Apple Wallet has the most share, with Samsung Pay being next, and then different types of independent provider wallets following. And in terms of the benefits for why people felt, why that growth and what people saw as the benefits in the use of digital wallets, contactless payment, less clutter, less fear of losing their cards, were perceived as the top benefits for using wallets as a digital payment method. No, wallets are not yet seen or reported in this group as a digital identity method. I would argue they're part of a collective. So, so interesting data from the market on their understanding of the digital wallet space. Now, this is one of my favorite slides and questions that we've asked for 2 years now in the audience. Now, where we started was a very low understanding of the audience. That's gone up to just over half last year, of the concept of digital identity. When we ask Canadians about, do they want access, do they want transparency and access to data about them that is collected and issued by government agencies and private companies, overwhelmingly, 91% say they strongly to somewhat agree that they want transparency, access, and control of data issued and collected about them by provincial governments. And then similarly, 91 to 92%, they want that transparency, access, and control to data issued and access, managed about them by the federal government. So we've never seen numbers as high as in the 90s in our surveys, and so that's fascinating to me. And then interestingly, we asked the same question about private companies, and a little bit lower in terms of that demand, but still very, very high. So 87% last year want that same transparency and control of data about them that's issued and managed by private sector organizations. So to underline this slide and why it's so important to me is when we ask people about digital identity, they can be quite confused, or they have many different models or concepts of what digital identity is or what it can be, the benefits and the risks. When we ask people about personal data control and transparency around that personal data, overwhelmingly, emotionally, naturally, people understand the concept of personal data control, and that's something that they demand. So I think in terms of responding to our market, this tells us this is something that people of all types of backgrounds across Canada understand and demand for them and their needs. Now, from looking at the last 3 years, we have asked Canadians, would they, 3 options. So moving forward on a framework for how to move forward with digital identity from a Canadian perspective, we've asked them for 3 options. Would they prefer public and private sector to work together collaboratively? Would they prefer governments alone to take a lead? Or would they prefer private sector alone to take a lead? And year over year, the strong voice of support is that the public and the private sector work together. So this is great news. I think what we've seen in terms of why people want the public and the private sector to work together is that they feel they provide checks and balances on each other to make sure that the design is around people and not too far in kind of one direction or the other. Interestingly, year over year, the responses around wanting public sector to go alone or private sector to go alone, year over year, those have been about equal. I think they've been about 13% each for people who want each to go alone and lead on the file. And interestingly, this year, the desire for government to go alone went down, and the desire for private sector to go alone went up. So 12% to 17% preferring private sector to go alone. And I think that tracks with the Edelman Trust Barometer and the declining trust globally in institutions as well as new and emerging technologies. So I think that tracks with other data that we've seen out in the ecosystem. So overall, Canadians are concerned about their information being compromised. Particularly, they're concerned about senior scams and identity theft. And we do have an opportunity to educate Canadians, particularly about what digital identity the benefits that it provides for privacy protection and personal data control. So they're only somewhat knowledgeable in that space. So we need to help connect those dots for the public. And that's one piece of building public trust. So a little bit on knowing our market. So let's talk about de-risking adoption. Certainly, there are a lot of factors in terms of de-risking adoption. And within the DIAC, we've developed a 5-year strategic plan for our organization. We're in years 3 through 5 now, and that means we're in our third focus, our third pillar, which is focused on obtaining the broad understanding of the need and value for good digital identity. We'll talk about a little bit about what the characteristics, from our view, of what good digital identity, what the design principles are as we go forward. Now, the digital identity space, I think the confusion there is rightfully so. There's a lot of complexity in our space. And we can talk about distributed technologies, blockchain, verifiable credentials, cryptography. So there are many different, even to user IDs and passwords, there are many different elements and ways and features authentication, access management. It's a complex space, let's face it. So one of the tools that we've developed a couple of tools that we'll feature today to help to build public trust and work through complexity. Excuse me. The first tool that we'll and our marquee tool that we'll discuss today is a Pan-Canadian Trust Framework. And this is a risk management framework that provides practical definitions for outcomes that must be achieved, that we can put against solutions to verify that they are de-risking, along with the use cases that those tools will be used in. And that verification that they've put their risk management practices in place will help to de-risk adoption. And as of and in November of last year, we also put out a white paper as a collaboration with the Human Technology Foundation to identify policy design principles for how to maximize the people-centered benefits of digital identity, which is a shared, from our perspective of two organizations, shared European and Canadian perspectives. I want to underline this here as well to say that the space that we're in, digital identity, and I'm sure, everywhere that technology and society intersects, it's not only technology versus business versus government and kind of how we'll each move forward. It's really the collective and how we move forward together for society. And that's part of what we're doing our part from the side of DIAC as a part of a whole and a collective in a complicated space. So let's look a little bit about the Pan-Canadian Trust Framework. It's a risk management framework that helps put standards, technology, policy, and governance into context. It sets auditable criteria for risk management to mitigate risk and to verify that policy and governance outcomes have been met, all in the service of people. And it's the people in their personal lives, in the context of their daily individual lives, or in the context of the work that they're doing in the organization that they're with and from an organizational perspective. If we look at that a little bit of a different way, we'll take a pyramid approach. And at the bottom of our pyramid, in terms of the how, we've got a lot of method definitions. And so I know that, there's talk in this community of different methods and cryptography. So let's say for your industry standards, national, international standards, and open source code that define a method or a set of methods. And then the Pan-Canadian Trust Framework is a risk management framework that defines compliance and defines a duty of care for how people and partners and organizations would reasonably expect their data and their experience to be cared for when they're interacting with these services. Now, the level of risk that the service is operating in and the solution is operating in is often set by the use case or cases or the communities that are adopting those methods, those solutions, and need to make sure, have assurance that the risk has been managed to help them adopt and to make sure that their community is as safe as it reasonably can be. And that's where we sit. So looking at that in a little bit more detail, our framework is componentized. So it's a set of documents all online in English and in French. And so we've got some informative components, some normative components, each individual documentations, and we've got all encompassing around privacy. So the informative components really help to lay out definitions of the model, whereas the specified or normative components set out auditable criteria for each functionality, like authentication, like digital wallets. And then all-encompassing is privacy that's woven into every component there within. So for example, we know that the digital wallet technology space is evolving and there's not a singular technology yet, and there may never be. And so what we lay out in the Pan-Canadian Trust Framework are the outcomes to be met to know that risk has been adequately managed for the community that's using that wallet or that technology. We are not defining the technology itself. It's the auditable criteria to verify risk has been managed. We've also got coming soon a component for trust registries. So these are registries that would actually be able to remove some of the complexity from the person using these tools and show you only those wallets that have been verified, for example, or only those credential providers or issuers that have been verified, just as an example. So that's coming soon. Now, underlining all of this is our Voila Verified program. So this is a third-party conformity assessment program that is out and launched in the ecosystem. We, through this program, we qualify and accredit information security auditors to perform third-party audits, independent audits. We accredit readiness advisors to help organizations through the process, testing labs to do the technology testing along the way. Ultimately to verify those services and solutions with a trust mark, and to have a public registry. We'll be having a public registry that shows the different certifications and trust marks and the metadata around them. You can think here that we would actually be users of our trust registry component in that space. So that's a little bit about the program that we underline and support it with. If you're someone who is into the ISO space of things, we've built to be aligned with audit and certification processes for ISO 17065, and we are going through our ISO accreditation currently for 17065 as a certifying body, as we are also operating currently as an industry body. So we're evolving ourselves through this process as well. So what's our opportunity? I'm really thankful for the opportunity to be here to speak with you, for the talks that I've got an opportunity to learn from through this conference. And I think this conference is a great example of where and how we can continue to collaborate, to share information and knowledge and work together on these topics. And particularly for DIAC, we'd love to work with you on how we can educate and reduce uncertainty around digital identity for data and personal data privacy, to help secure and de-risk adoption of those users, of those organizations who would benefit from this space. So we appreciate your time today. And I don't know, I think I might have a couple of minutes to have some dialogue. So thanks so much for joining us today.
Thank you for giving this. Yeah, so there's 5 minutes at least if you want to ask questions in the chat. Let me ask you kind of a boring question. So all your like user surveys and things like that, can you talk a bit about the methodology, like how, like, do you phone people? Do you like, and how does that, like, how do you make sure that you're sort of reaching average Canadians and that kind of thing?
Yeah, we use a qualified third-party research firm. So they're the ones that set the sample. So we rely on them. That's their expertise. So we contract with a third-party qualified research firm. They set the sample as their expertise and practice. And as part of that, it's making sure that we've got representative demographics across Canada, English and French, and in all of the different jurisdictions from different demographics to respond to us. Now we know, doing surveys and creating these and having these representative samples is really, really challenging. So, that's why we rely and we contract that with a third-party qualified firm. So that said, yeah, that's the methodology that we use for that. And I do think that I can't underline it more from the talk prior to this one. I've spent 20 years in this space working on digital trust and identity, standards and innovation, and helping to inform policy. And I do think that it always has been a confusing topic. When I tell my family what I do, they often think I'm in some sort of spy agency. They can't make heads or tails of what. But if I say to them, hey, how many user IDs and passwords do you have? And they say, oh my God, too many. Or even worse, they say, I have one. I use one and I use it for everything. Then kind of people who are not in this space and not working in it every day start to understand a little bit more. So, what I would say in general is to, for us as practitioners, we have one set of language that we speak with each other on those technological methods, those policy and governance needs. When we speak out to the public, I think it's really, really important that we're talking about the benefits and the use cases, and not talking to my mom about cryptography. She's not going to understand it. She just needs it to work, and she needs, what she does understand is, and my mom's in the US, but what she does understand, and I have to help her with from here. I'm half of a caregiver generation from my mom. I have to do her enrollments for, when she's gotten a lab test or when she's gotten a test at the hospital and she wants to see those results. And they're still using at least and there's more than one place to go to do those things. And they're still using, for some of those solutions, knowledge-based authentication and knowledge-based verification. So they're asking me questions that I'm trying to ask to her, like, what's your social security number? And did you ever have an investment here? And she's petrified to give that information. So people know there's something wrong. They know they're inconvenienced. They want to feel safe and in control. And us as practitioners, that's for us to work together on the policy and the technology for how that works. We also have a responsibility to speak with them in language that they can understand about the pain points they have and the benefits that they can feel too as well.
Awesome. Cyrus, you have a question? You want to just unmute yourself and ask?
Sure. Thanks for the opportunity. Joni, that was an excellent talk. Thank you for that. I have purely out of curiosity, I have a question regarding, your users in the surveys. Well, when we look at currently available physical identities, they're often all, in fact, I can't think of an instance where it's not. They're all issued by government, various levels of government, and they're also consumed by government, various levels of government. So how do you square that with digital ID and the increasing notion that the public has around public-private partnership? And how does that factor into the trust built into that ID? Could you comment on that?
Yeah, I love that question. And you should come join the DIAC and sit with us if these are things you want to discuss, because this is, we're having a jam next week, and this is what we'll be talking about. One of the key topics. Yeah, no, it's a great question. So if we think about digital identity, the practice and the space and technologies and methods, I really look at it as a data ecosystem. So we have a big, broad data ecosystem, and data about me personally, or who I work for, or that I'm a Canadian citizen. That data exists out all in different places in the ecosystem. And some of those sources are authoritative and some of those sources are non-authoritative. What I don't have today is I don't have the ability to really control or know where all that information is and be able to access it and use it. And so the question that you've asked actually sits at the heart of a lot of where our challenge is in this space. And so from a governance perspective, in the Canadian ecosystem, I immigrated to Canada, so my legal instantiation for who I am legally sits with Immigration and Refugees Canada. There was a deep vetting process and a permanent resident card, which is a really strong government issued credential. For those Canadians not born in Canada, your root sits with your province or your territory. And we know for sure, or I can say for sure, that a credential of a birth certificate and a credential of a permanent resident card are not the same things. However, from a, you don't have a picture or a biometric, and like they're just not the same things. But from a policy perspective, a birth certificate and a permanent resident card are both considered the same thing, which is called foundational identity. So there's a mismatch. We've got 18th century policy for 21st century ecosystem. So our policy has to modernize. So there are different non-authoritative bodies where public sector jurisdictions speak with each other about how they will work together. And there are big challenges there, because the work that we're doing and the methods and technologies being discussed at this conference, for example, finance is federally regulated, and a lot of our use cases are in finance. But then that root of government issued ID, that legal root of who you are, is distributed. And it's not sitting with one data authority. And in fact, the federal government of Canada is the largest customer of authoritative identity data from a government perspective. So absolutely, we are calling on and urging and informing the discussions between public sector entities on how they solve the problem of recognizing that they're issuers, recognizing that what that means in terms of their policy and process. And quite frankly, for example, I'm in British Columbia, and I know in British Columbia, there's the freedom of information policy. So I have the right to tell the government of British Columbia they have to give me access to all of my data. doesn't mean that the data needs to be in an interoperable and usable format that I can actually then go and use it out in the economy. So there absolutely is a policy gap. In Canada, the privacy policy is starting to modernize, but in my view, the privacy policy really talks a lot about protection of personal data, and it talks about protection of personal data in the private sector, but it doesn't define does government have a duty to tell me what data exists about me and that they issue and manage? And does government have the authority to actually give me that data in a usable and interoperable format or formats that I could use in digital wallets or distributed networks or different methodologies? So I think that from the root of government issued ID, I hope, and what we hope try to, there are big P policy issues that need to be addressed, and we're helping to advocate for those to get to the place where we will have usable digital government issued credentials that are not trackable, that protect privacy and enhance transparency. That said, we know that the internet, we're moving at the speed of Web3, Web4. We just keep moving and moving and moving in AI. So the ecosystem is trying to figure out ways of the next best way for how to solve these challenges. And so, for example, when the question around authoritative data comes up, you really have to look at that use case. Do you need a government issued ID? Who is asking the question based on the use case to verify me? Or will you trust, is it sufficient that I've been a TD customer for the last 15 years and I have a TD credential? And then does that open liability to TD? And what's the accountability framework around that? No picking on TD. I'm a TD customer, and just so that's why I'm picking on them. I think they're awesome. But that said, so that's where it comes down to risk management. We often use this metaphor when I arrived in our organization of the connecting Canada and digital identity verification as a railroad. And I think that was a great metaphor. But again, it's an 18th century metaphor for a 21st century world. And really what we do today is we have railways, we have roads, we take cars on, we have motorcycles, bicycles, vans, we have boats, we have planes. So we have a transportation ecosystem with different ways of achieving the outcomes that we need to achieve. Each have different risk profiles associated with them, and we've got structures to help manage that. So I think in Canada, we have to look less for a singular railway, a singular method for how we get these verifications done, and think more as a data ecosystem where multiple methodologies do exist, and we layer risk management verification on top of that, so the communities who are ready to adopt and need to adopt can do so, knowing that their risk has been reasonably mitigated.
Perfect.
Excellent answer.
Thank you. Okay, that's all we have time for. So thank you very much, Tony. And Cyrus, if you want to just stay on your video, you'll be our next speaker. So Cyrus Minuela is at the Bank of Canada. You might think he's an economist. He's not. He's on the technology side, engineering side, and he's going to talk about CBDCs. You're on mute.
Oh, thanks, Jeremy. How do I go about sharing?
Just there should be a green button called share screen.
Okay, thank you.
Follow the prompts.
Sorry, we don't use Zoom much in our.
Yeah, I know you guys use Teams. Teams.
That's right.
On my Apple is like, anyways, it takes five. It takes 5. I have to join meetings 5 minutes in advance so that it can actually fire up and get going by the time the meeting starts. Anyways, take it away. Thank you.
Oh, perfect. Let me see if I can turn on presentation mode. Is that working?
Yeah, we hear you. We see it. Looks good.
And it's in presentation mode?
And it's in like just the slide, so we can't see your notes or anything.
Perfect. Thank you, Jeremy. And thank you for inviting me to speak to this conference. And thank you to Ade as well. It's a pleasure to be here. It's a bit of a technical talk, so I'll dive in. And, Jeremy, feel free to cut me off if I go over time. There's a lot of results, even though I've tried to be selective. So, hi, everyone. I sort of lead the security work regarding central bank digital currencies at the Bank of Canada. And so today I'm presenting one of our experiments as internal research, but we've decided to make it public for various reasons. And it's around post-quantum cryptography and crypto agility in CBDCs. And this work was done in conjunction with my colleagues Fong Lei and Raza Kazmi, who are cryptographers at the bank. There's a disclaimer there. The views are expressed here and are those of the authors and do not necessarily reflect the official position of the bank, but I can say we officially did this work. Okay, so just a really brief primer for those who may not be fully aware of what money is. So the central bank is responsible for the supply of fiat money in the system, and this typically takes the form of banknotes. So we are responsible for printing all of the banknotes in Canada. Additionally, we have other key pillars of policy that we're responsible for. We're responsible for financial stability, and that's achieved through monetary policy. We are responsible for sovereignty, monetary sovereignty. And of course, we're the fiscal agent of the bank, which means that we participate in whenever the government issues bonds, we are the provider of the auction service for those bonds. So we negotiate between sellers and buyers. Now, when it comes to fiat money has to embody three attributes, and all three must be satisfied for it to be called fiat money. So fiat money has to be a medium of exchange. First of all, you can use it in transactions. Second, it's a store of value, which is self-explanatory. And finally, it's a unit of account, which means you can measure or quantify goods and services in fiat money. Now, CBDC, another really quick primer. CBDC is essentially fiat digital money. So it's the digital version of fiat money. And the critical part here is that it's money backed by the central bank, which explicitly means that the central bank is responsible for the issuance, redemption, life cycle. So we're responsible for creating money, introducing it into the system, and we're also responsible for destroying money. There are various properties of interest that we consider for CBDC. It must work at scale. We're thinking, at least 10,000. Oh, there's a zero missing there. It should be 10,000. My apologies. And maybe grow to 10 to 100 times over the life cycle as we move forward into micropayments, into IoT, into new technologies. It should be able to grow. We want to make sure it enables the digital economy. So it should be a platform for value-added products, which means we're not thinking of just a single closed system, but rather more of a service that other people can build their products on top of. We call it a mixed model approach internally. It must be accessible to everyone. We want to make sure because the bank is a public institution, and in some senses, money is considered to be a public good, although I know some economists who would disagree with that. We'll take the notion that we're on board with the fact that it is something we want to provide to everyone. So that includes unbanked and unphoned. The numbers for those tend to be very low in Canada, around 2 to 3%. Underbanked are a bit higher. And so often in the private sector, this is something that's easily ignored because there's not much market share there. But for a federal institution, public institution, we have to be cognizant of those folks. And finally, what this presentation is leading into is it must be private and secure. So this is core to the confidence in money. And just a disclaimer out there, there's a decision currently to issue CBDC. So everything I'm presenting is research on a contingency basis. The decision of whether to move forward with CBDC does not rest with the Bank of Canada. It is a parliamentary decision. Okay. With that out of the way, I can just jump into the project itself. So it took, for the better part of a year, we've been looking at post-quantum cryptography and how we can factor that into CBDC design. And it started with this broad goal, which is we want to assess the impact of quantum safe cryptography on an operational environment. And for those of you who are cryptographers or are well-versed in cryptography, I sort of use quantum safe and post-quantum interchangeably. The language change is fairly new for me, so I haven't fully adapted to using quantum safe everywhere. So please bear with me. So we're looking at assessing the impact of PQC on an operational environment. And we want to look at where the environment actually contains different entities with different levels of support and different capabilities, and they may need to interact with each other. And so this is, you can think of from a CBDC perspective, this is a payments ecosystem, and I'll dive a bit more into that later. Of course, we're looking to develop an open SSL library. And of course, many exist with a post-quantum support, libOQS being the mainstay that we see. And actually, we use libOQS in this project. And so we want to make sure, though, that libOQS has support for these various clients that will have different sort of capabilities and configurations. And then we're looking for classical, which is typical, existing TLS. We're looking at quantum safe, and we're also looking at hybrid mechanisms. So this would be hybrid, which is classical and quantum safe chems and signatures, so not just chems. Then we collect benchmarks, storage, bandwidth overhead, so mainly latency across the use cases. And finally, we want to make this library available publicly, so other people can use it, build on top of it. Additionally, because one of our use cases was a consensus mechanism, and I'll dive into that. The modifications we made to the consensus mechanism to support this library would also be available publicly. Okay, so why do this? From our perspective, CBDC is a long-lived system, which means if it is chosen to go operational, it is going to have a long shelf life. That means that we need to be prepared from an agility perspective. We need to be prepared to change or upgrade or update any underlying cryptographic primitive, or any primitive for that matter. A particular implementation of that primitive, maybe it's just a key size change, and so on. And this has to be able to be done operationally. So we want to minimize the amount of downtime that the system experiences while that's operational, because we have fairly high uptime targets for CBDC. We know that any cryptographic primitive or protocol or system we can currently consider to be secure could be broken tomorrow. We had some recent experiences, the most unfortunate being Psych being pulled out of the PQC competition. And given that Psych was one of the purely Canadian contributions, or mainly Canadian contributions, it's doubly unfortunate. But we noticed that. We noticed that attacks happen. We noticed that suddenly a rainbow's key sizes needed to increase dramatically, and so on and so forth. So we can't take it for gratis that any algorithm. So everybody hinges their emphasis on AES right now. But we don't know if AES is just around the corner from being broken. So we have to be prepared. And we can actually use quantum computing as a driver. We know quantum computers will exist at some point. And for a long-lived system, when they exist, they will be a threat to existing asymmetric key algorithms. And this is not just data that will be encrypted forward-facing for quantum computers, but also data that was historically encrypted. And many folks would already know this. So I'm not necessarily saying something new, but just keeping CBDC in mind and a system that may live 50, 70 years, these elements suddenly become crucial. And that means we need to think about them at the point of design, very early on. And we're thinking of CBDC design at this point. So that's where the learning opportunities come in, the impact of crypto agility, thinking about, do we include PQC from inception or develop a path to migration? And that really depends on some of the other qualities that we look at around performance and scalability, whether it's reasonable to start with PQC from the get-go. And of course, more broadly, we want to contribute to the public forum and demonstrate our commitment to the ecosystem. And some of the deciding factors are the effort of integration and backwards compatibility in addition to performance. So in terms of methodology, what we're really focusing on is just TLS. So in this case, it's TLS 1.3 we specifically picked because that's the industry standard right now to build a trusted, secure channel between any two computers. And the focus is on the handshake, the TLS handshake that happens right at the start before and the end of the handshake, you have a trusted channel with a bulk cipher. And so the focus is the key encapsulation mechanisms and the signature algorithms that we use in TLS. And our example use case here that's illustrated in the chart in front of you is basically a very simple transaction. So in this case, it's a check balance and a retrieve balance that I'm demonstrating here. But in the system, we actually have balance updates as well. My apologies. We have balance updates as well. So this would be assuming that a CBDC system looks like a very straightforward account system. And some transactions are submitted to those accounts. And we consider a mixture of platforms that I'll dive into. And we're testing both hybrid key agreement and hybrid signatures. So we're benchmarking both sets. Okay, a little bit of a touch base and a primer sort of what we mean by hybrid. And there are these definitions that cryptographers use, and we want to make sure we're talking about the exact same thing here. So typically when people refer to a hybrid crypto system, it's not by default assumed to be PQC merged with classical algorithms. A hybrid crypto system is essentially the merger of an asymmetric encryption algorithm with a symmetric encryption algorithm. So the idea is you use asymmetric encryption to encapsulate the key that will be used to construct the shared secret. And then once the shared secret is securely communicated between both parties, and additionally, both parties authenticate each other, you can proceed with symmetric encryption for any data transfer, and that would be a bulk cipher. So we're not thinking of a hybrid crypto system in the formal sense here. What we're really talking about is a hybrid key agreement protocol and a hybrid signature scheme. So in a hybrid key agreement, the client and the server would actually go about and they would generate ephemeral keys. This would be asymmetric encryption. So these would be ephemeral key pairs on both sides. And there would be one set for a classical. So there'd be a classical algorithm and there'd be a post-quantum algorithm. And then the key shards that would be used for the bulk cipher would be encapsulated by either or in a cascade or by both. So if it's either, this would be a composite OR scheme. This is probably the least secure. What is proposed in LibOQS by Doug Stebel and others is a composite AND scheme. And that's what we use for the duration of this project. But it could also be cascaded. And this is, we're finding more common in Europe, where they would have a key encapsulation mechanism, a handshake done with a classical scheme, and then the handshake would repeat with a post-quantum scheme. The advantage of having a library which supports multiple algorithms, so you can think of an ecosystem where there are multiple services of varying capabilities geographically distributed across Canada serving CBDC. And then you have clients of multiple capabilities also geographically distributed. And so we want to make sure that if we do an upgrade, we can perform a rolling upgrade so that clients can be upgraded piecemeal and servers can be upgraded piecemeal. We feel that this would be the mechanism for minimizing disruption in the system. So if you have unsupported clients and servers, they default to ECDH, ECDSA, the classical crypto algorithms that TLS 1.3 supports. And if you have supported devices, they would use hybrid, or at some point when we trust PQC enough, we could switch over entirely to PQC potentially. And just by way of reference, LibOQS's implementation of OpenSSL defaults to hybrid chem, and this is a concatenation composite AND. So this would be Kyber 512 and ECDH is the standard. Similarly for signature, I don't know if a decision has been made, but it's ECDSA plus, I suspect it's dilithium, but I'm not 100% sure. Okay, in terms of security levels, how do you decide the difficulty to test? So we use the NIST strength ratings as guidelines, and they are equivalent to a symmetric encryption algorithms such as AES or hash functions such as SHA-3. In our case, we had to limit our testing to categories 1 and 3. And mainly this was driven by the platforms we had around smartphone and IoT, because we expect, and it actually happened that way, that there are compute and memory bottlenecks for IoT platforms. So level 1 corresponds to a block cipher with 128-bit AES key, and level 3 corresponds to a block cipher with 192-bit AES key. Okay, in terms of the primitives we tested, so at the top, we have the very baseline primitives. Let me just turn on. Okay, yep, that's perfect. So these are the baseline. This would be what is supported traditionally in TLS 1.3, the classical algorithms. These are SecP256R1 or 384R1 curves. And then with the chem combinations, the chems and the signatures were combined. So there was this is just the post-quantum aspect here with Falcon or dilithium or Sphinx for level 1. And then we tested Kyber 512, Bike L1, HQC 128. Bike and HQC are code-based, and Kyber and Lightsaber are lattice-based. And then we had the hybrid version of that, merged with ECDSA B256 and ECDH B256. And similarly, we did the same thing for level 3, except for level 3, we only tested lithium 3 as the signature for the post-quantum variant. But we tested all the other algorithms, so Kyber, Bike, HQC, and Saber as well, with the appropriate bit depth to achieve level 3 security. Okay, let's see. Well, let me clear that. Okay, so we had 4 use cases. The use case that might be the most relevant here at this conference might be the distributed ledger use case. So in the distributed ledger use case, we had the client to DLT broadcast. So this is a consensus mechanism. I'll have another slide. I'll dive into the specific consensus mechanism we used. And every yellow arrow you see there basically represents the TLS 1.3 point-to-point connection between different nodes in the DLT. So we actually used Hot Stuff. Hot Stuff is now open source. It's based on Byzantine fault tolerance, as most people know, who work in this space. It was created actually for DM by Facebook. Well, previously Facebook, now Meta. And DM used to be previously called Calibra, and it's been open source since 2021. One of the nice things about Hot Stuff, and the reason why we used it, is because it uses basically a standard TLS connection between nodes operating on the blockchain. And I think the library is called something like libsalticidae, and we basically upgraded libsalticidae to support hybrid and post-quantum algorithms. Within Hot Stuff, the consensus mechanism is 3-phase, and it has 2 pre-consensus steps. So there's an election step and a prepare step. In the election step, participating nodes select a leader for the next block. This is optional. The leader can be static, fixed, or can move according to a very specific algorithm. The second step is the leader assembles the next block based on the available transactions and circulates to the nodes for voting. And there are 2 voting phases. There's a pre-commit phase where the nodes sign the leader's proposed block. That's called a pre-commitment. And finally, that's followed by a commit phase where the pre-committed block is circulated for voting. And because it's BFT, it's relying on the fact that n is at least 2n plus, 2f plus 1. So roughly, it says 3f plus 1, my apologies. It wants to make sure that at least 66% of the nodes in the system are not colluding or faulty. And if that's the case, if 66% or more of the majority is legitimate or honest, I should say, then the vote proceeds and the block is accepted and the blockchain remains secure. If more than 33% of the nodes are malicious, then they could manipulate the blockchain. Additionally, we studied point-to-point use cases, the client to server, the desktop. This is the baseline effectively. This is what we expect. And additionally, we also modified SSL on an Android smartphone, and we connected that to the web service, and we tested that. And finally, we wanted to demonstrate or measure the performance on an IoT device as a smart card representative. And so we picked a low power, low performance board that was similar to the CPU and memory design of a typical smart card that's used in payments. And we simulated that. And this is what that setup looks like. This is an STM board, 32F4 family, a very low memory. This only has 160 kilobytes of RAM, a CPU that's around 100 megahertz, which is similar to what is available on modern smart cards. And in particular, it has single precision floating point, and the floating point performance is quite slow. It turned out that this was the main bottleneck, so we only tested certain L1 and L3 chems, and we could not test any hybrid signature schemes. Okay. I have run into the time wall. I'm at 2. Jeremy, any thoughts? How much time do we have?
You started your talk about 10 minutes late, so whatever. The day slips. That's what happens with conferences. So take another 5 minutes or whatever you need, and that would leave 5 minutes for questions.
Okay, perfect. Okay, so I'll just demo a TLS exchange, and I'll just jump to our findings directly. So in this case, this is on the IoT device. On the left-hand side, we have the board initiating a client hello. And on the right-hand side, we actually have the server. And that's it. When it says connection closed, then we've established the handshake. And I mean, it took about 20 seconds to establish that handshake, but this was mainly with debugging turned on. Typically, it took on average of 1 second on the IoT board. So there are many plots. Unfortunately, we don't have time to go through all the plots, which is very normal. So we'll just jump directly to the observations. And if there are any questions, please feel free to ask, and I can go to the plots and use them to answer them. So from our observations, we found that there are certain configurations of optimized versions of PQC algorithms that actually incur minimal overhead when we compare to the baseline of classical. And our baseline is ECDH plus ECDSA, as I said. And we found that this was true both on the compute side and on the memory consumption side. We did note that the key sizes are obviously larger. So this was in particular for code-based primitives. And yet, for greenfield systems, it looked like, if we were careful in our choice, it seems that we could consider PQC from the get-go. If we could trust it from the get-go, we could run with Kyber 768 and dilithium 3. Because if you use that pure post-quantum approach, it's actually much faster. So when I say much faster, what we did was we measured the round trip time, which we call the latency in our plots. So the round trip time from when a transaction was submitted to the time where it was approved and finalized on the end user device. And we found in almost all the systems we tested, Kyber and dilithium was faster than ECDH and ECDSA. And this was a welcome development. Now, certainly, if you have a hybrid key agreement and a hybrid signature, it could minimize disruption, but it does incur a penalty. Once again, if you choose your parameters carefully, if you choose Kyber 768 at dilithium 3, the penalty is fairly small. You're only paying a 5% overhead in terms of the latency or the round trip time here. So that's also very interesting. So it's actually a promising development from our perspective. And this we noticed across all 4 use cases. Now, when it comes to PQC algorithms and how doable they are on IoT and other smaller devices, we found that smartphones, because of the performance of modern CPUs on smartphones are actually quite capable. And even though there's a bit of an extra hump, in terms of performance that they have to jump over, it's not too onerous. Once again, I can go through the plots and we can discuss the details. But smartphones can achieve PQC today, and they can also achieve hybrid schemes. It fits well within the compute and memory envelope of the phones. But IoT is still quite difficult. We couldn't test any hybrid signature schemes, as I mentioned. We could test post-quantum schemes. In particular, code-based schemes ran out of memory, so we couldn't test any level 3 code-based schemes. But it may turn out that over the next 3 to 5 years, the hardware catches up and there's accelerators or crypto accelerators or crypto support available on these devices that can actually leverage some of the operations. So the minimum factor there, the limiting factor, was the fact that there isn't much single instruction multiple data support, which really benefits lattice-based operations. IoT devices are missing those. And of course, floating point support is also weaker than desktop and smartphone CPUs. Some challenges we faced, I already mentioned the IoT ones. Android, interestingly, upgrading the SSL kernel was non-trivial because the system, the OS kernel, relied on a very specific version of the SSL kernel. So we had to compile it for the OS we were testing. Then we ran into another bottleneck with some of the algorithms where the memory alignment techniques on a desktop CPU were not available in the Android environment. And some of the pragmas failed. So we had to go in and debug those. That took a longer time than expected because it was such a low-level bug. We also had to be very careful about turning off logs within the system because they had a huge impact on the benchmarks. And similarly for our PQ hot stuff, we used Ansible to deploy to multiple nodes, configure them, populate the binaries. One of the things we had to change was we had to change OpenSSL to force it to use a very specific algorithm and be able to specify that on the command line. So still future work, but I'll just very much a work in progress, more to learn, but I'll just jump directly to questions in the interest of time. Thank you. Thank you for having me.
Great, thanks. So yeah, everyone just drop your questions in chat. I'll just ask a couple. So first off, for IoT, so the key size is obviously like one of the big issues. Was it just like they didn't have enough RAM, so they couldn't do it at all, or was it they could do it, it couldn't keep up with like many connections per second?
Well, so it wasn't just the key size. So what we did was we benchmarked the overall application stack, because in IoT, the memory map is very flat on the board. So that includes code, that includes all memory allocated on the stack and all memory allocated on the heap. So we weren't measuring just the key size for the specific algorithm. We measured the overall memory footprint of the application itself. And we found that on the IoT side, we just ran out of heap size or stack size. Well, in IoT, the stack and the heap are just different points in the memory map because it's flat.
Sure. But it ran out, so like it will not complete the algorithm. Like it's impossible to use. Yeah.
Correct. It's with 160 KB, we ran out. For Bike L3, we couldn't achieve it. And the code-based ones, we know they take up more memory. Kyber and Lightsaber were actually quite manageable. So we were able to implement those. And so this is what the typical stack looks like, running a Kyber and Saber chem. Okay,
great. A question from the chat from our next speaker, Doug. What approaches are other jurisdictions doing? How important is it to take in foreign developments as a design consideration within, say, Canada, the Bank of Canada?
Is this pertaining to CBDC holistically, or crypto agility, or something narrower? Sorry, just a clarification.
Right.
The cryptography.
We look very carefully. I would say we subscribe very much to, we don't necessarily want to invent any cryptography at the bank. And so we borrow from works that NIST does. We heavily scrutinize that. We follow cryptographers. We hired cryptographers specifically because we take it very seriously. So I would say, yeah, no cryptography will be invented at the bank. We won't be using anything baked like a CBAS or anything like that. That's not going to happen. Does that answer the question?
Well, sure, but it's more deciding between different cryptographic strategies. How much importance is there in alignment with other jurisdictions?
Okay, a lot of, that's a good question. When we talk to other CBs, so I'll speak specifically to that, there seems to be broad alignment that we don't want to invent our crypto. So everybody's looking to the standards bodies, and the standard bodies are different. So if you look at North America, everyone looks to NIST to see what they recommend. And most people will try to use the NIST approved algorithms. In Europe, it's a bit different. They would look at some other standards bodies. Germany has its own. And so the German IT, I forget the precise name for it, it's a long name. They have a government IT group that puts out recommendations for what institutions in Germany should use. So Germany will follow those recommendations. Similarly for France. So they may be slightly different, but it's being led at a jurisdictional level. The CVs, because we are not cryptographic experts, will resort to the guidance that we get from those bodies. So for example, Bank of Canada gets guidance from the Canadian Centre for Cybersecurity. That's our local source. And so we would use, if they had a specific recommendation for a specific algorithm that was approved or vetted, we would strongly consider that, unless it perhaps did not satisfy one of our policy goals. So if there was a privacy enhancing technique that required a specific algorithm, if the privacy goal is paramount, then we would pursue research into vetting or developing or vetting that algorithm. But in that case, the step would be that we would go to CCCS and say, we would like to use this algorithm. Can you help us vet it? So in the end, we would turn it into one of the approved algorithms. Hopefully that answers it.
Thanks.
Okay, good. In the interest of time, we'll move on. Doug asked another question in chat, but maybe Cyrus, you can answer that question in the chat itself.
Sure.
Okay, great.
Thank you.
Okay, so Doug, do you want to fire up? We heard you, obviously, so your mic works if you want to get your screen going.
Sure. Hey, everyone.
So Douglas Heinzman is at the Blockchain Research Institute, and he's going to give a kind of encapsulation of the whole Web3 sphere. World is the word used. Yeah, thanks.
Can you guys see the screen there?
Yeah, everything looks good. We can hear you and see you.
Okay, wonderful. Yeah, it's been fascinating kind of listening in to both a lot of the technical discussions as well as some of the more conceptual discussions. What I hope to accomplish here is to put a lot of these discussions into a broader context and talk about the impact that they're likely going to have on business and society in general. So there is this broader context that I think we have to take into consideration as we look forward and try to figure out where do we go from here. There's lots of challenges that we're faced with, ranging from supply chains to rates of adoption to issues around the demographics and the healthcare sector burdening, the transitions in the energy sector, as well as the environmental and sustainability issues, and the whole question of what it means to have an identity. There's lots of demand pull for change, ranging from deteriorating social trust to regulation and taxation, concerns about, AI superintelligence, to ESG concerns, to the fluctuations in the DeFi and space, digital currency, cyber tax, et cetera. So there's lots and lots of reasons that there's a lot of demand out there. And what we're seeing is, of course, a natural progression of the evolution of core infrastructure. These are foundational technologies. And so the Web3 world is kind of where we're heading to, and blockchain's a big part of that. The way that we kind of look at this is increasingly in this broader context of a group of technologies that seem to be coalescing in a mutually reinforcing way into a platform that we just broadly consider, that we broadly call kind of Web3. And it really has these four major components to it. It has a core state and runtime engine, which increasingly will be based on public and some hybrid blockchain with some bespoke engines in there. And this really is the record of the transactional record, as well as support for some basic automation capabilities. And those are the services being provided by blockchain. But the three other components that are kind of interesting, and as I get into some of the use cases, why this is so important will become much more evident, are the prediction decision support of AI, the measurement and actuation of IoT, and the spatial UX capabilities of AR, VR. And so these things seem to be coalescing And we also seem to be increasingly getting towards an inflection point. And I'll talk a little bit more about the signs that suggest that we're going to inflect. So there's a few other kind of just setup ideas here that will broadly shape the structure of the world that we will likely be moving into moving forward. The first is that machine-to-machine interactions and transaction volume will be absolutely huge, and that these systems are going to need to be able to have a common ledgering capability with a lot of confidence of identity. So identity just isn't just about people. It's about these various different devices and, what they claim to be, who they claim to have authorized them, what they claim their capabilities are, what their accuracy and margins of errors are, et cetera. And there's going to be massive transaction volumes. There's going to be smart contract coordination between a lot of these different elements, and transaction costs are going to be falling quite significantly by orders of magnitude. So this is one of the fundamental building blocks. Another interesting, I think, fundamental building block is the emergence of new governance models. The governance in the current system, where private companies own the state information, your bank owns your bank account balance information, your telco company owns your location history and your call history, Google owns your search history, Amazon owns your retail transaction history, that because of their ownership of the state, the value has been captured by a lot of these major technology platforms. And that's been the most notable mega business model in the Web 2 space. And it really is because of, there's a few natural monopoly and network effect considerations there, but an awful lot of the secret of the success of those business models is the fact that they own and can derive insight and control from that, from the state information. The question going forward is going to be, what happens when state becomes an inherent characteristic of the underlying network? And in that world, governance isn't the domain of a centralized, controlled by companies. It becomes much more decentralized, and value is increasingly captured by the ecosystem. And in many ways, this will kind of typify our transition from a corporate-dominated structure of business and society to much more of an ecosystem structure of business and society. Another piece of this puzzle is the concept of identity and what identity means. Once again, not just for people, but for things. And identity for people will largely be the basis of a new social contract. There's a lot of stress in the social contract right now, and we believe that some of these fundamental forces or new capabilities that are emerging in this new platform, coupled with a lot of the environmental stress and geopolitical stress that we are under, and the fact that we're in a late stage part of the debt cycle, that we're going to be crafting a new kind of social contract and a new definition of what identity really is all about will be a big part of that. I know we've discussed identity in some of the previous presentations, and so I won't go into this in too much detail, but I do want to kind of caution. I agree completely with one of the statements earlier about the trade-off between kind of the value that we get from the Faustian bargain that we've made with so many of these big platform companies, and just the ease of use by giving up our control of identity. And so we sacrifice some of our privacy in order to get access to high quality services. And I think there's a lot of truth in that. But I also think that there's a bit of a false comparison that we are just on the cusp of some new emerging technology that will change the balance, and where we decide that threshold is for which we would kind of sacrifice privacy for service. And so that balance is going to be changing. Another really kind of important building block concept is this idea of composability. And what I mean here is not just the traditional code composability, library composability from computer science, but a broader concept of business and societal composability. Fundamental infrastructure has always been the rails that we've built societies and economies on, and advances in that infrastructure have allowed us to be increasingly composable. And so if you kind of look historically, there have been many examples of foundational technologies, of course, transportation systems such as rail systems and road systems and electrical grids are all foundational technologies, the internet itself. But perhaps, one of the best historical examples is the introduction of, in pretty close proximity to each other, of two very fundamental foundational technologies. One, a permissionless communication protocol that was called the printing press, and one was a system of codification of assets, which was a ledger-based double account reentry system. And these two innovations led to a tremendous explosion of innovation and wealth creation. It allowed for the emergence of the very first stock exchanges, the invention of capitalism, and the Renaissance, the Enlightenment, the scientific revolution, and the first industrial revolution, and of course set the basis for the second and third industrial revolutions as well. So we see these things come along, and they result in substantial inflection points. What's interesting here is that the introduction of a lot of these technologies in the 1500s and their facilitation of the emergence of capitalism in the 1600s, the inflection point for the first and second industrial revolutions in the late 1700s and late 1800s took quite a while, right? Took the better part of 150, 200 years. But that was largely because of the complementary infrastructures that they were able to leverage at the time, because of very, very low degrees of literacy, very inefficient transportation networks, that we didn't have highly efficient collaboration networks. And as history's gone on, the time between the innovation and the inflection point has increasingly become compressed. And so we believe that the transition to the Web3 world will actually happen a lot faster in as few as 10 to 15 years before it's kind of substantially in place. So it'll be considerably accelerated relative to historical precedents. I'm going to talk about just kind of quickly go through a list of some of the major industries that are being impacted. And there's a few examples of kind of what I'll call obvious use case examples, right? So I do a lot of work in oil and gas, and there's just lots of things like post-trade settlements and of course carbon tracing and carbon marketplaces, lots of contract coordination. There's lots of regulatory compliance issues, and there's just lots and lots of use cases in the space. And that's also true of industries like rail systems, that along various different axes, there's lots of obvious use cases that are going to allow these systems to be somewhat more efficient. But what is really kind of, I think, a little more interesting is fundamental transformation. And there's a few industries out there that we believe are going to be pretty fundamentally transformed. The first one I talk about is banking and finance. This phenomena was actually started, the transformation of these industries was actually originally started outside the context of blockchain, and really just had to do with the huge amount of power that the banks own, once again, because of the fact that they own this state information, and governments wanting them to be more efficient, more innovative, and for customers to have more choice and have less friction of change. They implemented various different open data regulations, and especially been driven out of Europe. But open banking, open financing, open data kind of forced these governments to expose the state information via APIs to various different fintech applications that increasingly have started to disintermediate them from customers and are providing enhanced services. They're more nimble and can address marginal economic niches more efficiently. So we've been watching this phenomenon, and at the same time, we've seen what's happening in the DeFi space, and the fact that DeFi has been able to leverage composability so aggressively to assemble various different key components and manifest all kinds of new offerings that are much more fit for purpose, and the economic support creating innovative offerings for increasingly small audiences. So this was kind of the first piece of the equation. But what we think is going to happen is that the banking sector itself will be marginalized, that banks will increasingly have to focus on core banking services that are typically pretty regulated. And the banks that are going to prosper and succeed are going to be making much more of a commodity-oriented play that is going to be focused on, first of all, providing very high quality, very cost-effective, and very performant banking services, core banking services, but also providing very easy to use and compelling and comprehensive interfaces to those services. In turn, a lot of their customers, in fact, most of their customers are actually likely going to be neo-banking and neo-financial and integration services that will use the access to those core banking services and surround them with various different complementary services, including utility services and governmental services and environmental services and insurance services, and that consumers will more typically interact with those organizations. I've been talking to a bunch of major banks around the world, one of which it was kind of interesting because I showed them this chart and it made them incredibly nervous. And then I basically said, listen, there's two ways to really succeed and prosper. One is to become the best core banking service provider in your geography, and you're just going to be running huge transaction volumes, and you'll find all kinds of interesting ways to be profitable. But the second way is to, of course, to make investments and participate in this outer ring of neobanking financial services and integration services. And then I showed them a list of the top 25 banks in the world and showed them how collectively they had spent $16.8 billion investing in companies in this outer ring in the last 12 months. And then I said, of course, your company's not on that list. And they all turned white. But so I think there's going to be a lot of disruption in that space. And it's a very conservative industry. So that disruption is going to be really a big challenge to them. Another market that is also very conservative, and I walked into the president of a major insurance company, and he said basically, listen, my industry hasn't substantively innovated in 35 years, and there's a train coming at me at 100 kilometers an hour, and we're pretty scared. And I think that is right. There's going to be a lot of disruption in the current industry. There's the potential that there's a disruptive innovation play going on because the cost of being able to access marketplaces that are kind of long tail and more peripheral will fall dramatically, and thus expanding the overall marketplace. But there's going to be some players that will come in and address those marginal spaces with some new models, including peer-to-peer microinsurance and parametric insurance. And then they're going to evolve and mature those systems, and then they're going to threaten the core business of a lot of the incumbency. I think one of the really big opportunities in this space is to start thinking out of the box. So we take maritime insurance, for example. Right now, if you're going to insure goods in transport, you insure it typically at the container level, and you can insure it for about $500, regardless if it's filled with cardboard or if it's filled with iPhones. And that's just because there's just so much expense involved in setting up and monitoring and administrating the policies. And it's just so difficult to do any sort of actuarial assessment on all the variability in that space. But in a world where you have, AI doing a lot of prediction, IoT doing a lot of measurement, and the data being logged in real time across 5 and 6G telecommunication networks into authoritative ledgers, that all changes. You start to be able to administrate policies with much, much greater accuracy, and you start to be able to append insurance and hedging positions into international trade finance and all kinds of other industries. So I think there's big disruption coming to this marketplace, but there's vast, vast opportunity that this technology is going to uncover and expose. Another really interesting space beyond, in the energy space, beyond oil and gas, is the very fact that we are in transition, that the oil and gas industry as the backbone of the world's energy economy has a finite shelf life. A big part of it, of course, being transportation, which is being electrified at a rate that no one expected, or very few people expected, even 5 years ago. And with new legislation coming in that suggests that within the next 7 to 9 years, we're basically going to phase out or make illegal the sale of internal combustion engine vehicles, that we're going to see a pretty substantial transition in the energy sector. And there's a lot of cofactors driving this, which including falling prices in solar capture and storage, battery storage technology. But a lot of this is going to be about information, and it's going to be about the Web3 technology. So we think that the new world is going to be much more, instead of being about production and generation and distribution, it's going to be about distributed generation. It's going to be about distributed storage. It's going to be about demand response. For any of you who live in the Toronto area, over the weekend, it was announced that the city will actually pay you if you agree that your thermostat can be modified by up to 4 degrees 4 times a year. And so if you've got a smartish house with a smart thermostat, you can participate and help them regulate the stability of the grid. But we're going to see much more of those situations where your refrigerator will establish a smart contract with your utility provider, and that if there is tension and if there's instability on the grid, that they can make an arrangement where their demand can be cycled under certain situations, or for that matter, that energy that is stored in your wall battery or your car can be either put onto the grid or can absorb energy from the grid to help stabilize the grid. So this space will largely become a flow management space as opposed to a generation and distribution space. And that all of these systems will hopefully make the entire grid a lot more resilient as these groupings of distributed generation, storage, and demand response start to be assembled into microgrids that can balance out. So I'm on the west side of the street, and I'm selling electrons to my neighbor who's on the east side of the street in the morning, and he's selling them back to me in the evening. And that collectively we're storing things in our cars and in our houses, and that we're supplying energy to the microgrid to weather various different outages, et cetera, more efficiently. We're also going to see the service aggregators that we talked about in the banking and financial space, where a lot of those services, and as well as insurance, financial service, government, and carbon marketplace services, will be aggregated and visualized behind dashboards so that people can make relatively high-level policy decisions, and a collection of smart contracts will move tokens around to represent both the transfer of value as well as a demonstration of preference in voting. So I think there's going to be a lot of transformation in that industry as well. The supply chain space has been really interesting because, first of all, it's pretty messed up. It has an awful lot of participants that all kind of talk to each other. And for the most part, they use a system that is not dissimilar from the way that a lot of us move through traffic, where we communicate with the car in front of us and the car behind us by virtue of interpreting the signals from their lights and our perception and their change in velocity or direction. But we don't have a systemic view of the overall system unless we're using a system like Waze. Well, in a similar sort of way, everyone's recognized how fragile and rigid a lot of our supply chains are. And of course, the pandemic demonstrated a lot of the big problems in the supply chain and the challenge in doing stakeholder alignment. And a lot of us thought that blockchain was going to be this great solution to the supply chain space because, of course, logically speaking, if everyone's working off of a common record of the overall system, then each of the participants can make much better quality decisions, and the whole system becomes a lot more efficient, a lot more resilient. The challenge, of course, is that really hasn't quite played out nearly as well and as quickly as we had thought it would. I think that as the Web3 space starts to take place and we start to look at the addition of some of these other components, that this starts to become a much more likely scenario where AI starts to do an awful lot of the work about anticipating demand and supply and weather conditions and transportation constraints and bottlenecks, and that various different AI engines are contracting with other systems based on that insight and based on the fact that they have access to an authoritative state knowledge that is common to all the participants, giving everyone much greater situational awareness by virtue of IoT measurements. And that then you can get into this world of multi-party contracts, not only between the traditional participants in a supply chain, but also some of these new providers, new insurance providers, new financing providers, various different, service integrations or visualization or insight providers. So composability starts to become so compelling that the traditional problems of stakeholder alignment stop becoming the barrier to advancement in this space that it has been for the last 7 years or so. So I think there's going to be a lot of breakthrough as these technologies start to converge. And there's lots and lots of opportunities across the entire ecosystem, of course, and across supply chain because of this. So another interesting piece of this puzzle that I'm actually quite passionate about is what happens when you combine the circular economy with DeFi and a little bit of the solarpunk phenomena. You end up with this new space called refi, or regenerative finance. And the idea of, at the highest level, of leveraging the tokenization coming out of the blockchain world in order to much more efficiently incorporate the traditional economic externalities that a huge number of marketplaces currently have, both attributes as well as deficits and things like pollution that aren't currently incorporated into the pricing mechanism, that we end up with this new possibility to create frankly, a new kind of industry that not only is going to be a provider of new jobs, but is hopefully going to have a substantial impact on the viability of the planet. And so I'm kind of rooting for this, and at least logically speaking, a lot of the signs are that this is actually real. And it's not just that the technology is supporting new business models emerging in this space, but there is a substantial will and a want. There's a critical mass of especially young people that are quite passionate about this space. So there's a lot of just human energy being invested in this space. When I presented at the very first technical symposium many years ago now, I put up a variation of this slide talking about the seminal paper of Ronald Coase, and there's been subsequent papers by some of his students that really asked, what is the nature of the firm and why do businesses exist? One of the most interesting outcomes of the Web3 world is that it really has the potential of changing the nature of business architectures. It forces us to ask a very fundamental question, that what happens when the rationale for a company gets replaced with an inherent characteristic of an underlying network? That's a really profound question. And one of the logical implications is that we start to see an evolution in how business works, right? Where we're moving from, you could go further back in history to, guilds and proto corporations, but industrial age corporations, and then globally integrated enterprises and transnationals. There's various different configurations of companies. The information web has started to allow us to build business webs, and started us to have at least surface level or screen level integration of various different services. And AI has started to give us some insight about adjacencies, things like we see when we buy something off of Amazon. We can understand what an adjacent interesting product is and bring that into the realm of encouraging someone to put it into a basket. So we start to see business webs start to form, but the Web3 platform that we see emerging has the potential of allowing for a completely new structure, moving to an ecosystem economy where the vast majority of value isn't captured by a relatively small group of large corporations that are leveraging their either ownership of the state or the size and efficiency of the organization. That advantage starts to shift to much smaller economic actors that can compose and bind together and innovate at much, much faster rates than traditional companies, with the assumption that all of the trust factors and stakeholder alignment issues that were so fundamental to the rationale of the company are actually being supplied by the underlying network infrastructure. And that is a pretty radical thought. And it'll be absolutely fascinating to see what happens over the next 15 to 20 years in terms of the restructuring of the economy, and whether that new restructuring of the economy forms the basis of any new social contract that we may be putting in place. So there are some challenges, right? The technology is still immature. Markets are volatile. There's a lot of regulatory uncertainty, and things are moving at a rate and pace that regulations are not accustomed to dealing with. One of the most interesting observations that we've come to is that the enterprise blockchain model was wrong. I'll talk to that in just a quick sec. A lot of prominent business models in the space have failed. I'm not terribly concerned about that, because that's extremely typical at the advent of a new platform era. Building ecosystems is difficult, and has traditionally been difficult. One of the most interesting things about the Web3 world is that we have a new tool in these token-based distributed governance models that allow for stakeholder alignment to become much more market-based. And so we have a new kind of tool that may allow ecosystem formation and configuration and optimization to be much, much more efficient than it's been in the past. And there's a lot of misinformation out there. On the point that I was saying that the enterprise blockchain model was wrong, I think the issue is that when we're building systems, enterprise systems have to have kind of at least four major considerations, right? So they have to have scale. We talked about it a few sessions ago. They've got to have throughput. They have to have security, and they have to have transactional privacy. And the way that enterprises have been using blockchain has been to create a private little club and use a private permission sort of system in order to deal with those issues, because they could have much greater control and implement the core features that are required for enterprises to use technology. But and this was very much the same thing that happened in the 90s, where companies looked at the new internet technology and said, that's really interesting, but it's just not mature enough and doesn't have all of the characteristics that we need as an enterprise. So we're going to build intranets. But there was some point where the internet technology just evolved and incorporated the characteristics that they needed in terms of transactional privacy, security, throughput, and scalability. And then, of course, everything switched over. And the same thing happened with cloud computing. And it's typically about 8 years from the inflection point where public infrastructure takes on those core enterprise capabilities and gets to the point where they're good enough to start to deploy, to the point where over 50% of enterprise workload is deployed on that public infrastructure. That's been the historical norm. This shift may be faster because we just live in an era that has more velocity. It may take a little longer because there's some more complexity and there's other issues around. We just heard about the quantum threat, and that we may have to take into consideration and start to think about. But we think that we're pretty much at that inflection point in 2023. We've watched a lot of these enterprise models that we hoped had so much potential really not kind of pan out as well as we hoped that they would. And at the same time, we're seeing huge amounts of innovation in the public space and in a lot of bespoke chains. And we think that we're really at that inflection point where more and more enterprises are going to kind of come back and say, okay, there's now technology that we can actually leverage that will allow us to have those 4 characteristics. And we'll start to see an acceleration of adoption in the enterprise going forward. So when we're talking to clients, they always ask us, okay, what are the imperatives? And I think it's pretty simple, right? That there are a few use cases out there that this happens to be a more effective or productive or less costly option than incumbency. So applying it where it makes sense in operations, sure, go ahead. Carbon has to be incorporated into so many parts of our business landscape, and blockchain and the carbon marketplace is an important way to do that, because it allows you to kind of move dollars from carbon polluters to carbon mitigators or innovation that mitigates carbon. Leveraging the technology that's been fast. We heard about how the NFT space is, kind of taken a pause, and the whole DeFi space has been kind of shaken to its core. That being said, a vast amount of money has been spent on it, and a huge number of really, really smart people have been doing incredible work. There's a lot of technology there that can be learned from. And so leveraging that investment and leveraging the technology developed out of DeFi to solve some business problems is an obvious thing to do. Engaging stakeholders to develop ecosystems. More and more companies can't go it alone. And it's not just a matter of finding business partners or vendor relationships. It's about establishing multi-party relationships that lots of economic actors can attack a particular problem or a particular opportunity as a group. Explore co-investment opportunities, prepare for service composability as you're looking at your existing internal systems. Make the assumption that there's going to be magnified value if they are structured in ways that are highly composable. Build a center of excellence with the intention of concentrating excellence for rapid development, but with an eye to then taking those experts and then just sending them out to the entire organization to diffuse the information, and stay in the flow. The space is moving incredibly quickly. There's lots of great ideas, and you need to just stay very close to the conversation to really be able to leverage the fact that we seem to be at an important, maybe even historic inflection point, and that the world that we will see in 10 to 15 years is going to be quite different than the one we currently live in. Okay, there you go. I'm done.
Awesome. Thank you. Thank you so much. Any questions? Just drop them in the chat. We'll take a few minutes. So the one thing that struck me was you were talking about the disruption of the banking industry and trying to get banks to focus on their core product, which is payments. And then the previous talk is about CBDC. And so that's sort of like the government stepping in and actually like filling most of that circle and sort of disrupting them as well. So I was wondering if you have any thoughts about how a CBDC might like factor in.
I have a ton of thoughts on that. So the banks are very worried, and companies like Interact are very worried about CBDCs for a bunch of reasons, right? So retail financing is a very substantial amount of a lot of their business. And if people, especially in light of a lot of the bank failures in the States, put a lot of their capital into a government account, that they're basically taking that money out of banks. And not that doesn't only affect the bank's profitability, but it also affects the amount of usable capital that the banks have to turn around and give people mortgages and loans and that kind of thing. So there is this question about, it's I think it makes a ton of sense to have a digital currency. There's a huge amount of advantages, but there's a lot of knock-on effects that we're going to have to think through very carefully. There are certain banks and financial institutions and even geographies like Wyoming that are taking a slightly different approach. They say basically the fiat system works quite well. We just need a digital coinage. So we need a stable coin that has a peg and has currency characteristics and currency level stability, but allow us to interact with the payment rails with just, much more efficiency. So I think that, and then of course you've got UPI in India, and you've got Alipay, and there's lots and lots of examples of quasi-digital currency and payment systems out there. So this is a space that is changing really, really quickly and has just tremendously profound effects. And I think it's going to be very important. And I think Canada may have an advantage in this space, that banking is so concentrated that there's some potential you could get a critical mass of the core banks together to figure out what the right answer is for this particular geography, and work in partnership with the government to figure out, is it a CBDC? Is it a stable coin? Is it some hybrid between the two? And how do we deal with the knock-on effects of moving to digital currencies?
Great. And one other, I'll try and keep it quick, but it's a big question. What about like sort of more social issues? So like you mentioned, like AI leading to insurance. You have bias that appears in AI. You talked about composability. You have a lot of privacy issues with, data sellers and data brokers and those types of things. So what about those types of things like bias and privacy? And, what are your sort of thoughts around how we move forward with those issues?
Well, there's a whole bunch of questions there. So I think in privacy, I tend to kind of go back to fundamentals. In 1947, the UN defined privacy as a fundamental human right. And our system works as well as it does. There's lots of compromises that we make, but the fundamental concept of privacy is a pretty important core construct that allows us to have some sort of, social cohesion. And I don't think too many of us would want to live in a society that, we didn't have any privacy. Now, we all have some degree of we give up some degree of privacy and some degree of freedom. We drive on a certain side of the road so that the whole system works more efficiently. So we're always making some sort of compromises. But and then of course at the opposite end of the spectrum, you've got surveillance state stuff. So, it's going to be about finding the right balance. And I think that there may very well be usability advantages of things like self-sovereign. I mean, right now, as convenient as it is to have a Google ID and not leverage all the Google services, it's a pain in the ass to maintain so many of those for so many different kinds of systems. And especially once you're talking about highly regulated environments like finance, like healthcare, even just going from one doctor to another doctor, to a testing organization, to a specialist, to a hospital, the pain that there's so many different systems of retention is very cumbersome. And so identity is a big issue there. On bias, I think a lot of that discussion is going to be around AI and, what the training sets are. And I do think that that's a very, very important area that we're going to have to spend a lot of time thinking about to make sure that these potentially amazingly powerful and productive systems are, in service to our collective best interests.
Perfect. Okay, so that's all we have time for. But thank you very much. And we'll move on to the next speaker. So the next speaker is Patrick Mandic. Patrick, do you want to get your screen sharing going and test your mic?
Absolutely. Can you hear me okay?
Yeah. So Patrick is the CEO of MavenNet. So they do a lot of stuff in the energy industry, but other stuff as well around digital identity and things like that, I understand. So take it away. Thank you.
Yeah, thank you. And thanks, Doug, so much for the overview of the different industries. I am going to go down one specific example that Doug brought up, which is the supply chain, specifically focus on energy. And what I want to say is that what Doug said about the difference between intranet and internet, that switch that is happening in how we're applying blockchain, it's the key in this scenario, right? So we have barrels of oil that are identified digitally just in the domain of specific organizations, and that identification lose completely the meaning when the barrel goes down stream across the value chain. And so that is exactly what we're trying to address. We are moving from a set of intranets of digital islands to an internet of digital information for energy. I'm going to try to go relatively quick because unfortunately, I'm going to have to drop at 3:15, 3:20 at the latest. However, please stop me if you have any question or anything you want to add or comment. I'd rather we have a conversation that, this just being one-way direction. So just use your hand gesture on Zoom if you want to stop me. Okay, so very quickly an intro about MavenNet. We're a product organization that focuses on taking new technologies and seeing how we can adopt those or use them in the context of traditional industries. And so one of the specific products that we've developed is NeoFlow. We've been working for 4 years now with Homeland Security, specifically to prove origination of barrels of oil and MMBTU of gas coming from Canada into the US. Massive market, $110 billion a year of commerce, right? So a very, very interesting market, very interesting industry. However, in a point where despite investing millions of dollars in digital infrastructure, they've plateaued, right? And so we're going to talk about what that means. Specifically, what we're building is this digital representation of a barrel of oil, which gives you a unique universal identifier for a barrel independently of what organization reads it. Think about the identifier for FedEx that identifies one product. Of course, FedEx has the end-to-end. In this case, is across different organizations, right? And this virtualization, if you will, of the concept of a barrel of oil opens the door to lots of other opportunities, right? So imagine this is the difference. Going back to the analogy of the internet, this is the difference between sharing data on an intranet and the creation of an IP packet that then allow you to create a lot of different applications on top of it, right? Whether it's Google Maps, Waze, whatever it is. So just a bit of a background for the oil and gas, about the oil and gas industry in Canada. So for the ones that are digitally oriented and haven't looked too much about, how the actual physical movement of oil happens, most of the Canadian oil that it's produced as bitumen and diluted with some different diluents to be able to make it flow through the pipeline. Most of our oil in Canada goes to the US to be refined and then comes back to Canada for, let's say, in Ontario, for example, the oil actually comes from the US, right? So it takes about 45 days to go from, let's say, Edmonton to Texas. So think about walking speed. During that time, the barrel of oil changes hands multiple times, right? So whether in terms of ownership or in terms of custody, right? Think about pipelines, think about storage, inspection, think about custom clearance, and reception of the refinery. And so the way information is exchanged across this value chain is essentially changing documentation. So, and this documentation, for the most part, means doc files, PDFs, can mean Excel files, it can mean an email. In some cases, like reporting to CR is a fax, right? So, and I want to say a lot of these, especially the shippers, they're fully digitalized. So these people have invested millions of dollars completely digitizing their infrastructure. But then when they're communicating with the next organization down the value chain, they're going to send a PDF. So all that digitization end to end completely disappears, right? And so the challenge here is, how do you get the industry to agree on one system, one standard to communicate? And that is the challenge, right? What are the interfaces that everyone is going to understand? Because each one of these organizations, even if they're digitized internally, they're using a completely different system, different taxonomies of the information, and so even if they exchange this information digitally, the identifier for a barrel of oil has no meaning outside of their domain. So what we've created is a system that captures events throughout the value chain and reports events, has each organization report event in a standard way. In a standard way, so we've chosen specifically verifiable credentials, where we are actually also active in standardization. We've chosen verifiable credentials because it allows us to have that model where I can issue a verifiable credential. I know who issued that verifiable credential. I know I can verify that the verifiable credential is correct, and it's portable, right? So I don't need to have issued that verifiable credential to show it to someone else. So using that as a foundation, as a building block, I'm able to create the end-to-end life cycle of a specific barrel. And so in our case, the reason why this is being used is for cross-border. So once you have the end-to-end information about that barrel, you're able to clear customs without having to do any additional steps, right? So you already have all that information. Plus, you're able, in our case, to prove the origination of that barrel of oil as being Canadian, which is what it's hindering right now the industry a little bit, because they're overpaying north of $100 million just because it's so hard to provide all the necessary documentation to prove that the barrel of oil actually comes from Canada, where, where else is it going to come, right? It's not financially reasonable that it would come from somewhere else, but still they're not able to prove it, so they can't apply for USMCA forgiveness, right, of the tariff. So this is the model which I mentioned that we're using. So we have, and I can share at the end the specific vocabulary that we're using for supply chain and specific for energy. But all the foundation is the issuance of verifiable credentials, the carrying those verifiable credentials, putting them in a context of what it's the relationship between these verifiable credentials, and then showing them to a third party. And so all this gets underpinned by blockchain in the sense that we're able to preserve the to show the timestamps on when an event actually happened. So it's a lot harder to backdate, but also we're able to show the change of ownership and avoid the challenges with double spend, right? So double spend can also happen when it comes to clearing customs, for example, right? So you can try to use the same credentials for a barrel that identify the birth of a barrel for two barrels, because there's a second barrel that comes from illegit sources, right? So that actually happens, and has happened before with that diluent, for example, right? Diluent from Peru that makes its way to Canada. You use more than 40%, so the resulting product becomes non-originated from Canada. So having conceptual the concept of virtual barrel of oil, very powerful, not just for the specific example of cross-border, as I mentioned, but it opens the door to do a lot of what Web3 originally intended to do in terms of trade finance, in terms of providing a secondary market that it's a lot more liquid, tokenization, and so on. Just we're going bottom up instead of top down, in the sense that we're going from the physical, identifying the physical barrel, and then abstracting that and getting into DeFi at the tail end. And this is something conceptual for us right now. It's a very long way, but there's a path to it. Suppose from going from the conceptual DeFi and then try to link it to the physical barrel, because that's the tough thing to do. So once you do it and you have one use case running, then you can start tackling all the other ones, right? So you can think about royalties, you can think about payment automation, you can think about all the premises from Industry 4.0 of, if there's an event that happens that, for example, the refinery can't take that specific shipment, then you readapt and maybe reroute that barrel of oil in real time without having a human having to interact with it. So once you have that language that represents what's happening in the physical layer, you can program that language, and you can do essentially anything you want, right? And add any kind of application that you can think of. And in my opinion, we have here six potential applications. More powerful are the applications that we haven't even thought about today, right? And so the thought is that this is an open system, and anyone can build their applications on top of it. The same way that going back to the internet analogy, once you have the rails, once you have the ability to communicate globally, then you can build applications on top of it. And so these are some examples of applications that we're currently tackling. Environmental passport, Doug already talked about it. So the same way that we have a digital passport for a barrel of oil crossing the border, we're using the same digital passport to stamp specific events of CO2 emissions specific to that barrel, right? So up to now, most of the emission tracking happens by industrial facility. It doesn't happen by specific product, right? And so this is very applicable for gas. There's lots of different gradients of gas that are used by heavy industry, like, for example, steel. And depending on what source you're using, your actual emissions might be of a difference of 40%. So it's really important that you are able to prove the environmental footprint of the gas that you're buying. Another one is we call it scheduler. It's essentially a window to all the barrels you own. You're able to understand where they are, the characteristics, all the analytics, and you're able to optimize your capacity, making sure that, for example, barrels are not front-loaded, and the refinery kills you because they can't process so much at the beginning of the month, and so on. What else? I'm going very, very quickly, but rather leave some time for questions. And so going back to what Doug was mentioning about adoption, right? So this is the key in traditional industries. And so ultimately, the fact that what we're building is only going to work if it gets to a certain level of adoption. You can have an amazing idea of how a digital world is going to happen, like I mentioned in terms of DeFi for oil using this technology, but unless there is a meaningful amount of adoption, it's not going to happen. And so the approach, it's no different than the approach that, for example, Uber and Facebook and all these network companies have followed to succeed. Right? So you focus on one specific use case, and try to build first an atomic network. And so think about on Facebook, the starting with a dorm. On Uber, they started in very specific geographies. And so once there is critical mass, then people start using it, right? And people realize that it would be dumb not using it. But until you get to that critical mass, then the system doesn't have enough value. Think about the person who had the first telephone, right? Not a lot of value. As people are jumping into the network, the value starts increasing exponentially. And so in our case, we focused on that specific use case of cross-border. We're right now we have about 75% of the industry in our pilot starting in August 14th, and then growing from there. Given that everyone is already using that standard to build other applications, to build other use cases, to expand the network geographically, right? And build new atomic networks connecting them, right? So, and that's how you ultimately scale. That's what we've seen. That's what we feel that has a lot of potential to tip an industry that is, energy is the second largest market in the world after money, right? So huge space. We are still in the early beginnings, but we hope that in the next 2 to 5 years, all North America is using a digital system. Middle East is starting to use the system, to import into the US, and we keep growing. Obviously, the more organizations that can jump and build additional applications on top of the network, the more value this network is going to have. So with that being said, thanks for everyone's time and attention. I know that you must really like blockchain, and if you're attending a blockchain conference at 3:30 on a beautiful Friday with this weather. So I'll turn it over to everyone if anyone has a comment or please ideas, anything that you found interesting. Would love to hear some feedback.
Sure. And the weather's not so beautiful in Montreal at the moment. It's a big thunderstorm. So if I lose power, then that's why.
So everyone is in the call is from Montreal. Is that what you're saying?
No, I think I might be the only. Well, there's maybe a handful of people. Most people are. We're all across Canada, so that's really good. So yeah, drop some questions in the chat. I'll just ask you. So in the supply chain, like sort of transport kind of mechanism, like how much of it is a tech issue and how much of it is more of a like trying to get buy-in from all the people that you need, like the transport companies, the government. I think you had in your graphic, you had like 5 or 6 people sort of feeding into the box. And then how do you go about doing that? Can you do it incrementally, or is it like a kind of system that only works when you get a critical mass?
So that's a great question. And it's very similar, going back to the Facebook analogy, right? So initially the technology is important because, well, it's a new technology and it's connecting people, but very quickly that technology becomes less important, and what's important is the value of the network, right? So it gets to the point where if you copy the source code, you can't do anything with it, right? Because you don't have the critical mass. And this is very, very similar. Once you have that initial technology, that initial breakthrough, the most important thing is getting to that critical mass. And our approach has been trying to align everyone by working with regulators, by working with governments, and try to elevate the waters for everyone in the industry at once, right? Now, as I mentioned, I feel it's very important to focus on those niche use cases first, because if you spread yourself thin and try to bring too many people, too many use cases with not enough participants for each use case, then it's not going to succeed.
Perfect. Okay, Juliet in the chat wants to connect with you, so maybe I'll let you drop her a message or something with your contact email.
Perfect.
And so I'm going to keep you on time. So you gave us back time on the conference, and I'll give it back to you as well. So thank you very much for joining us.
Thanks, everyone. Right on time. Thank you. Have a good rest of the conference.
Yeah, thanks. Okay, so next we'll move on to the student talks. So we have 3 of them lined up. So Guwen Liu, hopefully I'm saying that right.
Hi there, Jeremy. Can you hear me?
Hey, how are you? So if you want to throw your slides up in your camera.
Show my camera. Yeah, right now I'm in Ontario. This sunshine is very beautiful.
Nice. Perfect. Yeah. So Guwen's presumably in Waterloo. You're a student.
Yeah, exactly.
Yeah. So take it away.
Would you allow me to reopen my Zoom application, because I need to authenticate the Zoom
Okay.
for sharing the file. I didn't try that before. Excuse me.
No worries. Thanks. Everyone can take a quick bathroom break if they want to. Next time we do this, I'll definitely put some breaks in so that we can absorb time slippage and I can get up myself.
Sorry, Jeremy.
No worries.
Let me try to share screen again. Here. Can you see my slides right now?
Yeah, we can see it.
Okay, perfect. Hi, everyone. I'm Guiwen. Today, I'm going to talk about the computation of, do you only see the slides or you still see the Zoom window?
We don't see the Zoom window, so you only see
Okay.
that. Everyone else, we just see the
Because
slides.
on my screen, I see not only my slides, but also the
Yeah,
Zoom.
and you can drag it around if they're like covering up text.
Okay, thank you. So I'm going to talk about the computation of multiscalar multiplication over fixed points for the zk-SNARK applications. And these slides are based on the joint work with Sihui Fu and Professor Guang Gong. And this QR code is the link to the paper, which is published in CHESS 2023. Yeah, I will show the QR code after the presentation if you don't have time to scan it right now. So the problem we are going to investigate is the multiscalar multiplication over fixed points, which is denoted as S and R. Here, N is the number of the points. R is the upper bound of the scalar. Every AI is an integer or an scalar less than R, and every PI is a fixed point in an elliptic curve group E. Yeah, this is the equation for the definition of multiscalar multiplication. So the problem is, how can we compute it efficiently for large N? Say N is no less than 2 to the 10. For those of you who are not so familiar with the elliptic curve group operations, you could simply treat the PI here as a big integer, and you treat the point addition and the scalar multiplication here as the normal addition and multiplication in integer ring. That might help you understand those algorithms I'm going to introduce. So in this presentation, it is divided into 4 parts. First, I will introduce the motivation, and then I will introduce the state-of-the-art algorithm, which is Pippinger's bucket method. Next, I will present our method. And finally, I will show you the instantiation and some experimental result over BLS 12381 curve. And this curve is very popular in blockchain society. So that's why we do the instantiation over this curve. Well, the motivation is pretty clear because the multiscalar multiplication dominates the time consumption in zk-SNARK schemes with pairing-based trusted setup. Here, zk-SNARK is a popular tool to enable the privacy feature in blockchain applications. So those pairing-based trusted setup zk-SNARKs, they usually follow the same paradigm. That is, there is a public string composed of an array of fixed points in an elliptic curve group called common reference string. And the prover generates the proof by evaluating multiscalar multiplications in the over the points in the common reference string and by computing other operations. The verifier verifies the proof by computing multiscalar multiplications and bilinear pairings. So you could see basically S and R is an essential operation in pairing-based zk-SNARKs. I didn't do the investigation, but I know some of the paper, they investigate some of the popular zk-SNARK schemes. It turns out the multiscalar multiplication takes up more than 70% of the total time for proof generation. So which means this is very important. So here are 2 examples. Let's say if you want to use GR16. GR16 is a influential zk-SNARK protocol. If you want to use GR16 to prove the knowledge of the pre-image for a SHA-256 hash value, then the number of points n in the corresponding multiscalar multiplication is about 23,000. If you want to prove the membership in a 64 layer Merkle tree, then the number could be more than 1 million. This is the original setting in the Zcash paper, but now they changed their proof system, and they also changed the hash function. So Zprice as ZK organization, Zprice is hosting a competition for the fastest multi-scalar multiplication implementation. The winner of this competition could be awarded up to more than $1 million. By the way, right now this competition is open for registration. So if you are interested, you may sign it up. So basically all those things shows the importance of the multi-scalar multiplication in the ZK community. So as I mentioned, Pipinger's bucket method is the state-of-the-art algorithm. So as of today, some of the popular ZK snark implementations like Zcash, TurboPlunk, Bellman, Gnark, all of them choose Pipinger's bucket method to compute the multi-scalar multiplications. Well, what is Pipinger's bucket method? Let me quickly recap this method. Let's say if R is small, we define a subsum Sj. Sj is the sum of all those points whose scalar equals j. So by using this definition, we know that the multi-scalar multiplication SNR can be written as 1 times S1 plus 2 times S2 through R minus 1 times SR minus 1. This is because all those points Pi, they can be sorted into some of the subsum with respect to their scalars. Okay. So by after this step, we compute all those subsum Sj's using n minus R minus 1 point additions. This is because in total we have n points, but here we only have R minus 1 subsums. So you sorted out n points into R minus 1 subsums. So that's why it requires n minus R minus 1 additions. So what's left is the accumulation of j times Sj. This accumulation can be computed using 2 times R minus 2 additions. So to sum up, the multi-scalar multiplication requires n plus R minus 3 additions. This is obtained by add this term and this term together. So this is pretty ideal situation because in practice, R is pretty large. Recall that R is the order of the elliptic curve group. So in practice, for example, BLS 12381 curve, R is 255 bit. So in this situation, we first decompose every scalar into its Q-array form. So here the scalar AI is decomposed into its Q-array form, where every digit is less than Q. And the length of the expression is denoted as H. So by using this decomposition, we can rewrite the SNR as this form, basically by simply substituting the AI's decomposition. And if we rearrange this formula, so this term inside the parentheses, let's denote it as Sj. This term is a multi-scalar multiplication with n points, right? Because yeah, it's n points, and it has a special property that all those scalars Aij is no more than Q, is less than Q. So although we cannot directly use the previous method on S and R, but we can use the previous method to compute Sj. So that's the idea. So for all those Sj, there are H of them. So each Sj, it's an n-scalar multiplication where all those scalars are less than Q. So each Sj can be computed by n plus Q minus 3 additions. Here, you could treat the Q as the smaller r in the previous example. Then what's left is the accumulation of Q times J, Q to the J times Sj. This accumulation can be evaluated by a method similar to Horner's rule. Let's first write this as this equation. So the term inside the parentheses, Q times SH minus 1. Recall that Q is 2 to the C. So it can be evaluated by C doublings. Then we use another addition to compute the term inside the parentheses. So one term takes C plus 1 additions if we treat the doubling as the addition. And the cost is, let's treat them their cost as the same. So this process, we repeat it H minus 1 time, then we can evaluate, we obtain the final result. So this step requires H minus 1 times C plus 1 additions. So in total, by adding this term and this term together, the SNR requires approximately H times N plus Q additions. We ignore those small terms. So this is the Pippinger's bucket method. So for the decomposition, we choose all those digits from 0 to Q minus 1, right? But we can also choose all those digits from negative Q over 2 to Q over 2. So if we do this, the time complexity could be further reduced to H times N plus Q over 2 additions. So how can we do better? So this is our proposed framework. We not only decompose AI into its Q-array form, but also we further decompose every digit into a product of M times B. Here, the Mij is an element from a set that we called multiplayer set. And the Bij is an element from another set B, which we called bucket set. So if we can decompose every scalar into this form, then the multiscalar multiplication can be rewrite as this equation. Again, simply substitute the scalar using its decomposition expression. So this expression is actually a multiscalar multiplication with H times N points and with all the scalars from bucket set, if we treat this term as a single point. Okay, then how can we treat this term as a single point? Well, we use pre-computation. We pre-compute all the points who looks like this form, basically M times Q to the J times Pi. If we pre-compute all those points, then the original multiscalar multiplication will be equivalent to another H times N scalar multiplications whose scalars are from B. Okay, so after this step, we can use the method similar to the Pippinger's bucket method, and it can be evaluated by H times N plus the size of B point additions. So this is our framework. For example, the famous variant of Pippinger's bucket method, so-called BGMW method, it can be explained under this framework by using M as 1, -1, and the bucket set as 0 to q over 2. If we use this m and this b, according to the framework, this m and b will yield a method to compute S and R using n times h plus q over 2 additions. So what we did, well, under this framework, we construct a bucket set B for the multiplayer set -3 to 3, such that the size of the bucket set is approximately 0.21 times q. So according to the framework, this construction will yield a method for computing S and R using those many point additions with the help of 3 NH pre-computed points. So how do we construct the bucket set? For example, let's say for Q equals 32, and the multiplayer set is fixed as this. So our goal is to construct a set B such that all the scalars can be expressed into this expression where every digit is the product of an element B from the bucket set and another element M from the multiplayer set. Well, the most trivial construction is you could choose B as 0 to q minus 1. That definitely satisfies the requirement, right? But there are some redundancy. So for example, the upper half, we can actually delete them. Say if you need 17, you can obtain 17 by q minus 15. 15 is in this set. So by this step, we can halve the size of the bucket set. And we can do better because we have 2 and 3 in the multiplayer set. So all those elements that can obtained by multiply the elements by 2 or 3, we delete them. For example, here 8 is deleted because 8 can be obtained by 4 times 2. 15 is deleted because 15 is obtained by 5 times 3. Okay, here this bucket set construction, it's already small enough for our application, but we can do even better. Notice that because 6 can be replaced by 13 and 11 can be replaced by 7 because of those two expressions. So we can further delete 6 and 11 from this set. And this set, the final, this set is the final construction of our bucket set. Okay, this is a toy example. So by formalizing this toy example, we can get the algorithm that compute bucket set for arbitrary radix Q, where Q is 2 to the C. Here the definition, omega 2b refers to the exponent of factor 2 in the integer b. Here, omega 3b refers to the exponent of 3 in integer b. Let me check the time. Okay, I need to pick up the pace. So here is the instantiation for the bucket construction over BLS 12381 curve. You could see the size of the B compared to the Q, the ratio is approximately, most of the time, the ratio is 0.21. So according to the framework, we can obtain an efficient algorithm to compute S and R using so many additions. And here is the comparison for different methods. Here, the trivial method refers to the method where we first compute the scalar multiplication using the doubling and addition algorithm. Then we add all those intermediate results together. So from this table, you could see our algorithm provides the best time complexity. But the expense is the largest pre-computation size. Okay. Okay, what's left is the experimental result. I just quickly skip them because all the experiment validates the theoretical analysis. So to sum up, we provide a new we propose a new algorithm, and this algorithm shows a decent amount of improvement against the best algorithm so far. Yeah, I guess I will stop here and answer your questions. Oh,
Perfect. Thanks.
excuse me. Here is the QR code to the paper. If you want to learn more of the details and those mathematical formulas, please scan it and check the paper. Thank you.
Okay, if anyone has questions, drop it in the chat. I'll just ask one. I know you're focused on multiplication. What about the pairing operation itself? Does it use multiplications inside of it? Are there sort of optimizations that are similar to what you did that would apply?
No,
and then I guess in the SNARK case, like the prover doesn't have to do a pairing. I guess it's just the verifier does a couple at the end. So maybe it's not that important.
Actually, we don't have to do any optimization for pairing because pairing is very fast. Usually pairing is evaluated in several milliseconds, right? 1 million seconds or 2 million seconds, something like that. But
so my mental model is completely wrong if I think that the pairing operation is more expensive than the multiplication?
Multiscalar multiplication is way much expensive than pairing operations because multiscalar multiplication, for example, if n is a million, the computation would take a second. So in this comparison, the bottleneck is no longer the pairing computation. So we don't put lots of effort for improving the pairing computation.
Okay, got it. And this would show up in like ZK SNARK protocols like Planck, for example.
Planck and GR16, those two representatives. Yeah.
Okay.
As long as you use the common reference stream, usually the proof generation is done by evaluating the multiscalar multiplication, right? Yeah, that's the basic idea behind this paper.
Perfect.
Okay, thank you.
Okay, yeah, thanks a lot. Okay, we'll move on to the next speaker. So the next speaker is Preston Haffey. Do you want to unmute and start your video?
Okay, thank you, Jeremy.
Yeah, thanks a lot.
Hi, how's it going?
Very good. If you want to get your screen sharing. So Preston's a student at University of Calgary, and we'll talk about fair exchange protocols.
Yeah, hi, my name is Preston, and I have done some research with some team members, Sapida Avize, and my supervisor, Ray Safaviniani, on a fair exchange in smart contract-based fair exchange protocols. So I'll just kind of go through, here, let me start my presentation, I guess. Yeah, so I'll just go through and I'll talk about what a fair exchange is, why the kind of works that we worked off of, the solutions that they presented using blockchains, and then some of the problems that we found with privacy in their solutions, and then just a little bit on, you know, our modifications to their solutions to help introduce privacy. So first of all, we'll just talk about what a fair exchange is. So a fair exchange is just an exchange where two people or two parties have some items that they want to swap with each other. We could think of like a seller who has a digital good that they want to sell someone. So this could be like a file or some data. So examples are like a movie, an ebook, software. And this digital item has some properties. So for an ebook, this could be like the title, the author, the edition, etc. And a buyer, someone who's interested in purchasing this digital good in exchange for something. In our case, we consider the buyer has some coins or like some currency that they can buy this digital good from. So they could have money. This would be cash, check, e-transfer, or in the case of blockchains, it would be a cryptocurrency. And the buyer also has some preferences on what they want to spend their money on. So they might have authors that they like. If they're looking to buy a movie, they might want to only watch movies of a certain video quality. If they're going to buy some software, they want to make sure that it runs on their favorite operating systems. And so to kind of capture this quality of a buyer's preference, we can talk about a predicate, which is just kind of like a, we can just think of it as a small program that checks the properties of the digital item. So it would check, it could check the author of the ebook, it could check the file format of the movie to make sure that it would play 4K. Or in a more complicated predicate, we could even have a suite of unit tests that run on a specific software to make sure the software meets the specifications of the buyer here. Now, we say that the exchange between buyer and seller is fair when the buyer and seller get exactly what they want at the end of the exchange, or neither of them gets anything at all. So the seller, they'll say, I will sell my digital item for some money, only if that money you're giving me is valued at 100 Bitcoin or whatever the currency is. These are just kind of examples. And the buyer is saying, well, okay, I'm willing to pay the 100 for this digital item, but only if the digital item satisfies the properties that I'm wanting, right? I don't want to spend $100 on something that I didn't expect to actually get. And so the problem is over the internet, achieving fairness in exchange is very difficult. Essentially, one of the parties kind of needs to make the move first and send their part of the exchange and hope that the other party is honest and they follow through with their exchange. So to guarantee the fairness over the internet, we actually need a trusted third party to get involved. And just as an example, to make this a little bit more concrete, this isn't a digital item, but this is an example of in 2013, a teenager in Britain, they paid $735 for what they thought was a new Xbox, and they received a photo of an Xbox. So the seller on eBay, they did state in the ad that this was a photo, but put it in, the console section, and we're kind of being misleading in their in what they were advertising. And at the end of the day, the buyer, they needed to rely on eBay to help settle the dispute and get their money back for them. So how does the third party here work really? Well, we have our predicate that encodes the preferences of the buyer. And what we would do is we, using the third party in a naive way, the seller could send their item to the third party, and the buyer can send their money to the third party. And the third party is the one who does the check of the predicate to make sure that the item satisfies what the buyer wants. And then they'll also check the value of the currency they receive to make sure that they have enough to cover the costs that the seller is trying to sell the item for. And if everything's good, then the trusted third party is responsible for distributing these things in the exchange, or if some condition isn't met, then the third party is going to just return the items back to their original owners. One version of fair exchange protocols is called optimistic. So the idea here is that we have a trusted third party, but we only need to activate or get them involved when there's a dispute. So the two parties, they do this exchange directly, but there's an appeal process that one of the parties can turn to the trusted third party and complain. And the trusted third party is going to have some power to restore fairness to the exchange. So either ensure that both of them got what they wanted, or to undo the exchange and make sure that neither of them are kind of ahead from when the exchange is concluded. So for a roadmap for the rest of the presentation, I'll just go over the smart contract-based fair exchange, how these works, FairSwap and OptiSwap work. And so these are not our works; these are the works that we built on top. And we'll talk about the problem of information leakage in these protocols and how this affects the fair exchange, the fairness of the exchange that these protocols, FairSwap and OptiSwap, guaranteed. And then I'll also just talk a little bit at the end, our privacy enhanced versions of these protocols that still achieve the fairness, but address the privacy issue. So how could we use the smart contract as a trusted third party. So the original motivation for FairSwap and later OptiSwap is just an optimized version of FairSwap. But essentially the core idea is the same between these two works. Is it, instead of relying on a trusted third party, which might not be reasonable in practice, or if there is some magical fully trustable third party, it would probably be very expensive to employ. So FairSwap, what they notice is that, well, we can kind of remove the centralized trusted third party and replace this with a smart contract run on a blockchain here. So smart contracts are computer programs that are run on the blockchain network, and so their execution is decentralized, and we have the same trust in the execution of the program as we do in like the ledger state. So if we have Bitcoin and we trust that the balances of the Bitcoin accounts are maintained, we have the same level of trust in the integrity of the computation that's performed on the blockchain. And essentially what we do is we encode the predicate that does the checking of the properties into a smart contract. And the smart contract can also receive funds from the buyer and lock these funds until we're assured that the item that is being exchanged satisfies the properties, and then those funds can be released to the seller. Now, the problem, though, is that in public blockchains like Ethereum, the computational resources are very limited. So if we have a complicated predicate, or if our item is very large, it's just not feasible to do that kind of computation on the blockchain network. And so FairSwap came up with a clever idea on how to achieve essentially this level of fairness, but without having to do all of the computation on chain. So this is just a little bit of preliminaries to help us understand how FairSwap works. So first of all, when we have a digital item, we can think of it as a file. This is essentially a sequential sequence of ones and zeros, right? At the end of the day, our digital information, it's just stored in ones and zeros in the machine. So if we have a ebook starts once upon a time, we can represent this as the binary. And so this is just the ASCII code of once upon a time here. And then these, this big long string of ones and zeros, it could be segmented. And then each one of these segments, these 8 binary digits can be considered as a decimal value, for example. So these 8 binary digits here in decimal is equal to the number 79. So the next thing that's important is modeling computation as a circuit. So we can, we can compute anything that we want to compute if we do multiplication and addition over a finite field, as called an arithmetic circuit. And so modular multiplication and addition is basically just regular integer multiplication addition, but we divide the results by a number, the modulus. And so in this case, it's just an example. If I wanted to do 2 plus 3 mod 4, I would add 2 and 3 to get 5. And this equals 5, which could be expressed as 1 times 4 plus 1. So this is 4 plus a remainder of 1. And then we just take the remainder here. And then multiplication is the same. 1 times 2 is 2. 2 divided by 0 times 4 is 0, plus 2 is what this computation gives us here. And for the circuit here, we have input gates that are connected by wires to operation gates. So the values of the wire are fed into a gate. The operation performs an operation, and the result is carried out on this output gate here. And you can see how these kind of gates are composed together with these wires. And at the end, we have an output of the circuit here. Now, another 2 things, these are the kind of crypto concepts, but we don't need to know too much of them, just the kind of intuitive understanding. First is a commitment scheme. So commitments allow us to commit to some value that we don't have to reveal. So I can compute a commitment on a value X, and I get a commitment C and an opening D. And later I can show someone what this commitment committed to by revealing the opening D and the value that I committed to X. And this open algorithm here outputs a 0 or 1, depending on whether this is a valid opening to the commitment. And the commitment is it has hiding and binding. So when I commit to my value X and I give someone the commitment C, it's hiding. So it doesn't tell anyone anything about what X was, and it's binding. So when I later reveal a value, I can't change, I can't give them a different value than what I committed to. Only the value that I originally committed the commitment for is going to be opened. And then the other key element here is symmetric encryption, which is a basic encryption. We have a key generation to get a symmetric key, then we can encrypt a message under this key to get a ciphertext C, and then we can decrypt the ciphertext using the same key to recover our message M. And the important part here for security is that C, seeing the ciphertext C, it doesn't give us any information about what the message that it encrypts is, or what the key used to encrypt it was. Okay, so in this setting here, this smart contract based fair exchange, we express the predicate as this circuit computation. And the circuit, the description of the circuit here is public, and it encodes the preferences of the buyer here. So they want the digital item such that when I put this digital item as an input into this circuit, it's going to output a result of 1. So this is public information, as well as what the price is I'm paying. This is also public information we assume in our model. Now, it's kind of an interesting cryptographic scenario here, because the digital good that the seller has, it's valuable because access is restricted to it. So it's not like I need to pay to get access. So in some way, it's a bit secret from me, but it's not a secret like an encryption key is necessarily. It's it's meant to be shared. And again, the coin here, it's obviously not a secret, but it's a resource that I need to restrict to, right? Not everyone can just take my money. I need to be able to decide who I send this money to. Yes, anyway, so we could have our digital item here, and because we know digital items are just 1s and 0s, which we can turn into decimal numbers, we can chunk up that digital item and feed it into this circuit, this predicate circuit. So here you can see if I chunk this X up into 2, 3, 1, and 2 into this arithmetic circuit, and it's executed, the output of the circuit is 3 based on these arithmetic operations here. Sorry, I don't know why this animation does this, but anyways, let's see. Let's suppose that we have a seller who wants to cheat the buyer, right? They have an item, and when it's fed into the circuit that encodes the buyer's preferences, it outputs a 3, like we saw in the last slide here. But what the buyer wants is they want something that outputs a 1. Well, the seller could cheat by corrupting one of these gates. So essentially, they just change the result of one of these wire values, such that the output still looks like it's what the buyer wants here. So here we're corrupting this multiplication gate, because 1 times 2 in mod 4, it should be 2, but we've changed it to 0, so that when we add it to the other wire here, the output is a 1, which is what the buyer wants, even though the input is not, doesn't actually satisfy the preferences of the buyer here. Yeah, again, sorry, don't know about that, but so how, so we've talked kind of about, the digital item, how the user has preferences, how we can encode this into a circuit, and how we can use the circuit to check that the item has the preferences. But we've also said how that a seller could cheat this circuit, right? So FairSwap, what they do is they give a protocol that helps us do this circuit exchange here in a way that's ensures that if the seller is cheating, that the buyer gets their money back. And if the seller actually sends something that does satisfy this circuit, they're guaranteed to get the coins from the buyer. And so basically just a very high level, what we do is we commit to some of these parameters of the exchange. We commit to the circuit, the description here. So we know which preferences we're agreeing to. We commit to the digital item that the seller is trying to sell. And then we generate an encryption key, and we also commit to this encryption key here. And then what the seller does is they execute their circuit, and then we okay, yeah, sorry about that. So the seller, they will encrypt all of they'll encrypt their digital item, and they'll encrypt all the wire values here of this circuit. And then they send all these encrypted values to the buyer. So then what happens is the seller, the buyer, sorry, they'll receive this encrypted information. They'll just compare what they received against the published commitments here to make sure that everything is consistent with this information. If everything looks good, the buyer is going to send the coins to the smart contract, who's going to lock them, so hold them there until the exchange is completed. And then the seller, they're going to send over the encrypted item and the encrypted wire values of this circuit here. Then after that, the buyer is going to say, okay, I'm ready for you to reveal the decryption key. So the seller sends over the key, and now this buyer can decrypt the digital item. So they recover the digital item, and they can decrypt all the wire values of the circuit to make sure that what they've received actually satisfies their preferences. Yes. Okay. So what in this case, because the seller cheated, they corrupted one of these gates, the buyer is going to be able to detect this now, that they've received the decryption key, they recovered all these wire values. So the buyer finds a misbehaving gate. So what they know is that the item that they were sent actually doesn't satisfy their preference because this gate has been manipulated by the seller. Yeah, sorry, these slides I adapted from another presentation, which I have these transitions, which I forgot about. And I know I'm running a little bit close on time too, but so we can prove to the smart contract that this computation was done incorrectly by revealing just a single gate to the smart contract. We can find this gate which is part of the circuit description, which was committed to in the very first phase. And then we can reveal the inputs to this gate that were committed to by the seller when they did their circuit execution, and send this to the smart contract, who can then just do the computation for this one gate and see that the input values on this gate operation are not actually what they should be. So the smart contract can see that the result of this 1 and 2 on a multiplication gate should be 2, but it's actually 0 that the seller committed to. And because the smart contract can do this, it can identify the cheating party, and it can send the coins back to the buyer if the cheating, if we can actually form this proof of misbehavior, or if everything is okay, or if the proof of misbehavior isn't valid, then they can send the coins to the seller. And in this way, we achieve the fair exchange. So one of the things that we noticed was that we have to leak some of the circuit computation, which could be some of the item that we wanted to sell. And just to give some context, when you buy an ebook from a publisher, they'll license you the ebook, and what they do is they watermark each page with your name and email address. So this is from a Reddit post. This is someone who bought this book. They were actually trying to find out how to remove this watermark. I mean, usually publishers put the watermark in there to prevent you from, distributing it in an unauthorized way. This person, I mean, obviously we don't condone it. They're trying to circumvent this, but we can see that when you buy something like an ebook, it contains personally identifiable information. And so, for example, my complaint that I submit, it could contain like my name and my email address. And then now my personal details are connected to this item that I wanted to buy. And we can remember too that the circuit here that encodes my preferences, this is public information. So now someone can, I basically have to tell the whole world what it is I wanted to buy in order to complain. And so the question we ask is like, well, does this leakage put the buyer in an awkward position where now they have to choose between getting the fairness guarantee or compromising their privacy? And what we did was we took a solution to protect hardware circuits where against wire probing attacks. So this is in a threat model where an adversary has access to some of these wires, and they can find the values on these wires. And we found that this is basically what the smart contract does when it receives the proof of misinformation. And so the solution is basically to expand the circuit and to randomize the circuit using secret sharing. And so we replace all these gates with gadgets that perform the gate operation over the secret shared wires. And so basically secret sharing, if you're not familiar, we can take a secret and we can split it into multiple parts. And here we use perfect secret sharing. So any combination, so I have a secret S and I can split it into shares S1, S2, S3. And any combination of these two secret shares doesn't tell us anything about S. But if we have all three, then we can recover the secret, and we can also perform these computations over basically random looking data. And in this case, I can now perform we can run the circuit, the randomized circuit. And if there is an issue, it's still only going to be one of these gates. So I only have to reveal one part of the secret share to the smart contract, who could then verify that the gate was miscomputed, but without actually having to reveal any information about what the computation is. So these are some of the references for our work, and that's it. Thanks for listening.
Awesome, thanks. So I have 4 or 5 questions, but in the interest of time, I'll just maybe ask you one. So one thing you didn't talk about is the sort of the timing issues. So I mean, all fair exchanges have them. So if I want to prove misbehavior, there's probably like some time limit. And if I don't get my proof in on time, right, like the transaction goes through. Or so maybe you can say a few words about that. And then like MEV front running, like how you could, or censorship, like if there's ways to like sort of attack that part of the protocol.
Exactly. So in the threat model for fair swap, which is also part of in our privacy enhanced versions, we maintain this part, is that if you don't respond in a certain time, then we if the seller sends you the item and then releases the key, and then you don't respond, then we assume that everything's fine. So you as the buyer, you need to make sure that you can actually submit the complaint to the smart contract. But this, our work in fair swaps, we don't consider this kind of guaranteed delivery issue for this. Yeah.
And in practice, you have a sense of like what, like would that be minutes, days?
That's a good question. I think it depends on like the network you're using and the transaction throughput. You might. So it really depends.
Probably the value of the item too. Like it would. The more.
Exactly. I mean, you can give quite a large window to the buyer because even like if the seller is behaving correctly cryptographically, there's nothing that the buyer can do, even given a lot of time, to break the fairness. So the protocol, because of the cryptographic guarantees, it lets you be very lenient in this time. So,
got it. Okay, great. Thank you very much. And we'll move on to the very last talk of this year's edition. So it's, I guess, your colleague, Sepidita. We can see your screen if you can unmute yourself, and we'll make sure your microphone's working. So I don't hear you yet anyways.
Hello, can you hear me?
Yeah, perfect.
Okay, sounds good.
Okay, take it away. Thank you.
Hello, my name is Sepidita Vision. and today I'm presenting the research work delegation of computation using smart contracts. This project has been done in Esprit Lab, and it's a joint work with Mahmoud Al-Nabi and Professor Rayhan Safavi. Delegation of computation enables a weak client a weak client which has limited computational resources to outsource or delegate the computation to a more powerful server and then get back the result. It helps the organizations to expand their computational resources without the need to manage their computing infrastructure and saving on information technology costs. However, the issue is that the cloud server might not be trusted, and the client needs to verify the result. So the client doesn't need to, should not repeat the computation again. So we need an efficient verification mechanism to let the client verify the result. There are some works on the verifiable computations. Some of them are on probabilistic checkable proofs. Some of them are from argument systems, homomorphic encryption. But the most efficient ones are by replication. The computation is given to multiple cloud servers rather than one. And then the result is accepted if the majority of the clouds return the same result. Canetti, Roseblum, and Riva in 2011 designed a verifiable computation scheme that follows this replication, and it gives the computation to two independent clouds and guarantee correctness if at least one of them is honest. This scheme is also called referred delegation of computation, and I also sometimes use CRR interchangeably. There are some follow-up works that use a smart contract in place of the referee in these schemes. Some of them are, some examples are like TrueBit, HB, which consider rational adversary, and the others are smart contract-based CRR, committed CRR, and SCRDOC, which have been done by our research work, and it is secure against malicious adversary. In this talk, I'm going through the RDOC scheme and this gradual evolvement of the RDOC schemes in the smart contract setting, the SCCRR, committed CRR, and the two-party and multi-party SCRDOC in UC setting. And also I briefly go through the implementation of the SCRDOC, which is called FIDIS. Before going through RDOC, I just give some preliminaries. So here we consider the computation model as a Turing machine. Turing machine is a mathematical model. It's an abstract model that manipulates the characters in a tape according to a rule table. A Turing machine can be represented by a state, tape, and head. Canetti introduced the notion of reduced configuration, which rather than representing the tape, we just use two values. The character that is in the head of the tape and the hash value, which summarizes the tape. It is the root of the Merkle tree constructed on the tape. I sometimes use the execution trace in my presentation, which is the reduced configuration in different computation steps. And also I may use the array of reduced configurations, which is the array that contains these reduced configurations. The good thing about the reduced configuration is that if the verifier notes two consecutive steps, if it notes the reduced configuration, for example, at a step 2 and a step 3, and it also receives a Merkle proof for the step 2, he can verify the reduced configuration at the step 3 without having the tape contents, because this Merkle tree, because the Merkle proof contains the hashes that the hashes corresponds to the this tape contents. And when the step, it just manipulates one cell of the tape, so it just manipulates one element in the Merkle tree. So it can be verified, and the verifier can make sure whether the reduced configuration at step 3 is correct or not. So having all this in mind, I just now talk about the referred delegation of computation, how it works. So the client sends the computation function and the inputs to 2 cloud servers, and then they do the computation and return the result. If they return the same result, that result is considered correct because one of the servers is assumed to be honest. If the result doesn't match, then the client starts the interaction with the cloud servers to identify who is cheating. So the client will send queries and gives the responses. And these queries are in the form of index of the computation step, and the cloud servers return the reduced configuration at that step until the client can detect one diverging point. By diverging point, I mean that the computation before that step is same for cloud server 1 and cloud server 2, but the next step is different for the 2 servers. So the client can do the single step execution and find who is cheating. So this scheme has provable security. This is good, but it assumes that the client is trusted and it pays the cloud servers honestly. So if we want to relax this assumption, the first solution that comes to mind is using the smart contracts. The smart contract can receive the computation fee from the client, and it can interact with the cloud servers as a referee. It receives the result of the computation and decides who is cheating and pay the honest party the computation fee. But we noticed that this naive approach doesn't work. And the problem is that the communication in the blockchain network is not instantaneous. So there is a delay when Cloud 1 publishes the result of the computation. When it propagates through the network until it receives and confirmed in a block, there is a delay. And the cloud server 2 can see that result and it can copy it as its own result. So the smart contract see 2 same result and accept it as a correct one. But the cloud 2 hasn't done the computation. So, and this is removing the independence of the result. That was the basic, the first assumption in the RDOC. We also noticed that this gives an attractive strategy to the rational cloud. So here you see an action tree. It shows the sequence of actions of the 2 clouds. For example, cloud 1 at the top can either compute or doesn't compute and just reveal an incorrect result. The cloud 2, if cloud 1 computes, it can either compute, be malicious, or copy. So you see case 3 and case 5 are related to copy attack. In case 3, doesn't matter that it is doing the copy attack, the correctness is guaranteed because it is copying from the correct result. But in case 5, an incorrect result is returned to the client. But in both cases, the cloud who hasn't done the work will be rewarded. So this will disincentivize the honest behavior. So we proposed the confirmation protocol to protect against copy attack in SC-CRR scheme, which was published in 2019. And the confirmation protocol works like this. The cloud server 1 and 2 will reveal their computation result together with a Merkle root on the computation trace, on the execution trace of the Turing machine. And the smart contract will receive these and compares them. If they match with each other, then the smart contract will send a query to each of the clouds, to distinct queries, and the clouds will reply with a Merkle proof, P1 and P2, to the smart contract. Because in the case that the cloud server 2 has copied from cloud server 1, he cannot reply to the proof correctly. So it mitigates the copy attack. In this work, we didn't consider the copy attack during the binary search step when the client and the servers interact with each other to find the diverging point. This solution that the smart contract should generate random queries can be complex in practice and implementation. So in the follow-up paper, we use the commitment scheme to mitigate the copy attack. We call the scheme as committed CRR, which briefly works like this. The clouds first commit to the result. This commitment is personalized using the public key of the servers. So the result is concatenated with the public key, and then they commit to that. And then in the next round, they open the results. So if the server copies from the result of from the commitment of the first server, it cannot open it correctly with his own public key. And to mitigate the copy attack during the binary search step, we consider that both clouds also sends the Merkle root of their computation trace that is also concatenated with their public keys. And when they go to the binary search steps where the smart contract is sending query to find a diverging point, the cloud servers also reply with the Merkle proof for the reduced configuration of that queried step. And if the reduced configurations are the same, then the smart contract will verify the Merkle proof and detects who is cheating. So we use hash-based commitment, and considering that the hash is collision resistant, we prove that the protocol can achieve copy protection, soundness, and correctness. Till now, all these protocols had game-based security. In another work, we adapted the committed CRR protocol to the UC setting. We called it the new work as a smart contract RDOC or SCRDOC, which defines the smart contract-based referred delegation of computation in UC model and formalizes it. And it formalized the ideal functionality, which captures correctness, soundness, and copy attack in the ledger setting. And this UC security allows us to have composable security, so we can prove security of an N-server SCRDOC in this model. So we proposed the N-server SCRDOC scheme, which relaxes the trust assumption by considering that among N servers, at least one of them is honest. And it uses the two-party SCRDOC scheme as its subrouting. So it works like that. Each server engage in the two-party SCRDOC protocol with all other servers. And at the end, the smart contract should decide that who is cheating. Now the copy can also extend to copying from other sessions. So we consider that these protocol instances are run in parallel. And we analyzed the attacks that the servers can do, and found that what a smart contract should do to find a cheating party. I just showed some of the attacks. For example, the isolation attack that I have shown in a table. So here, this is kind of result table. Each row of the table shows that one server plays with all other servers, and the values that are in each cell shows what they have output in that protocol instance. For example, what S1 has revealed when it was playing with S2 or with S3. And the cross that I have indicated in this table is the abort, so means that S2 has aborted early in the protocol. So in the first table, in the left side, I'm considering that S1 is honest and S2, S3, and S4 are malicious. They can collude. And what they can do is they abort with in the protocols that engage with S1. So when they are going to play with S1, the protocol, they abort early. So they don't let the S1, which is the honest server, to publish its result. And when they play with each other, they return some incorrect output. So in this case, the smart contract may return the incorrect result. So we considered the early abort as a malicious behavior. So the smart contract, when it sees an early abort from some server, it marks that server as cheating. Another attack was framing attack, where the cheating parties, for example, S3 and S4 in the right side table, will reveal different outputs. When they play with honest parties, they reveal the correct result. When they play with malicious parties, they reveal a different result. So the smart contract cannot distinguish which one of them is correct. So to mitigate this attack, we considered that the smart contract should track the outputs, and then if any party reveals different outputs in 2 sessions, it has to be marked as cheating. So we proved that SCRDOC is secure in if the commitment scheme is used secure in a random oracle model. So I just skipped the details here, but if you have any questions, then I can answer more. I just briefly go to the implementation of SCRDOC, which is called FIDIS. In FIDIS, we use Ethereum smart contracts to implement the SCRDOC. Because the single step execution should be run in Ethereum, so we made some design choices. We considered that the computation function is written in Solidity language, and the servers run this program in their local EVM. And because the computation should be deterministic, we considered that the inputs are hard-coded to the delegated program. And if any randomness is required, then the random seed is hard-coded in the delegated program, and so the random number generator is used to generate the randomness that is required. And we also found the non-deterministic EVM instructions and removed them from the set of available instructions from the servers. Here you see the evaluation results. We considered a matrix multiplication as a computation function. In the left side, you see the execution cost in terms of time for different matrix sizes. And in the right side, it's the cost of different phases of the protocol based on gas, Ether, and US dollar. And it shows that the number of gases is within the block gas limit. And the cost is reasonable. It's 16, and in the case of result mismatch, it is $52, which this can be charged by the misbehaving parties. Just for this implementation, we just made another modification to the protocol. We didn't publish the program to the smart contract. We just committed to the computation program in the smart contract to reduce the storage cost. Yeah, so this was what we had for the SCRDOC. We had different versions of that, and we formalized it in UC. But still, there are some open issues. For example, analyzing the privacy of that, or there are different variants of RDOC now. So comparing these variants with each other, and also using the commonly used architectures for the implementation, rather than just considering the EVM. And thank you. For more information, please contact us. For the details for the implementation, you can send an email to Nabi. And yeah, that's it. Thank you.
Great. Thank you very much. So I assume you did this on Ethereum like 1.0, like before the proof of stake.
Yes.
So one thing that comes with proof of stake, I don't know if you've caught up on this, but you have to pick a leader at random. And so now there's like a lot of work on chain to produce random numbers that you can use for these like leader elections. So now you have numbers that are hard to manipulate on chain. So given that, if you went back to your older protocol that was using beacons as opposed to using commitments, would that be a less expensive protocol to run now that you have good randomness on chain?
Yeah, that's a good question. Actually, that scheme also has some merits. We can look at it in future works. But for example, the thing is that for the commitment, we need really synchronized communication because they should commit at the same time and open at the same time. But with that approach, we don't need this type of synchronization. So that also has some advantages. So I should study more on that to say that whether using that approach makes it less expensive or not, because we also want to mitigate the copy attack during the binary search. And yeah, maybe it can be the hybrid of both, considering that there is a random beacon in the result confirmation step, and the commitment in the binary search approach, maybe like that. But yeah, it needs further study.
Yeah. Okay, great. Okay, so that's it. Thank you very much. And yeah, so I'll just first off, thanks to everyone who stuck around to the very end. And let me just share my screen quickly. Ask me later. Okay, so I'll just announce that. Well, first off, thanks to everyone. So thank you thanks to Adi for co-organizing this. Thanks to the steering committee who kept on top of us and made sure that we pulled off an event this year. Thanks to all the speakers. The event obviously couldn't happen without you. So next year we'll be back. So we're planning a hybrid event. So this will hopefully consist of an in-person event, and we'll have a virtual component as well. So if you can't make it to the in-person event, we'll still have something for you. So just these dates are very tentative, but we've made some bookings of rooms and things like that. So we think that the in-person event would be like a Wednesday, Thursday, Friday of the week of May 29th. And it would be at Concordia University in Montreal. And then the Monday, Tuesday, we would have some sort of virtual programming as well. So anyways, thanks very much. And that concludes this year. And we hope to see you next year. We might shoot around a little survey. We like to do it just to get your feedback. And if you have ideas about things, and if you want to speak next year or anything like that, just reach out to us by email, and we're happy to hear your ideas and things like that. But we'll try and solicit those ideas from you as well. Okay, thanks, and enjoy the rest of your day, everyone.